morning everyone, but I think I would say good afternoon, good evening folks who are joining around the world. Since this is a live streaming on YouTube, and welcome to Kubernetes Day Sri Lanka 2022. Thank you so much for joining with us. It's so excited to be with you. Initially, we were planning to have all in person and get to know each other to share knowledge with you all. Unfortunately, we had to make this virtual event due to the prevailing constraint in Sri Lanka. Since this is our first ever Kubernetes Community Day event in Sri Lanka, you may be wondering what kind of event this is and how it will encourage you to upgrade your skills and get to know about cloud native products. We hope you folks get an idea about from our FAQ series. To tell you more, here's Camilla.
Thank you, Chamod. Kubernetes Community Days are community organized events that gather adapters, technologies from open source and cloud native communities to learn, collaborate, share knowledge, and network for the advancement in Kubernetes. Actually, not only Kubernetes. We will share the knowledge on any other related cloud native open source projects as well. So we would like to invite the person behind this extraordinary event in Sri Lanka, and he will join virtual from Melbourne. Here's Kanchana, who is the main organizer, Vice President and GM at WSO2.
Thank you, Camilla. Ayubowan, Vanakkam, and good day to everyone. I'm really excited to be here virtually with our two co-hosts, Chamod and Camilla, to bring you panel discussions, talks, technical sessions to follow with awesome speakers around the world. Before I go further, I would like to thank someone who has contributed a lot to CNCF in the advancement of Kubernetes and related events globally. That person, none other than late Dan Cohn, one of the most down-to-earth and humble human being I have met to date. I had the privilege of meeting him in Sydney, Australia during the Kubernetes days in 2019. He took time out of his busy schedule to have a chat with me and to tell me that he has traveled to Sri Lanka and fell in love with the people and the country. And one day he would like us, Sri Lankan Kubernetes community, to host a Kubernetes Community Day. Unfortunately, with the COVID and other challenges, we couldn't get this done before his death. However, in honoring him, this year we decided virtually we will host this session. And thank Dan for your support, and we will continue with the effort and awesome community contribution that you have started. Yes, as Chamod and Camilla, who spoke before me, we are very excited to have a line of exciting speakers around the globe to talk about Kubernetes and related cloud native projects. Without further ado, I'd like to introduce our third co-host, Chirag.
Thank you, Kanchan. Kubernetes is a complex platform and requires extensive configuration management. To keep Kubernetes workload safe, especially in production environment, you need to address key architectural vulnerabilities and platform dependencies by implementing security best practices. Here we have Nilesh, an accomplished software architect at WSO2 with over 10 years of experience. He is skilled in developing full stack development, cloud computing, DevOps, and SRE, and he is also an expert in all things related to Kubernetes and the cloud native stack. He was also instrumental in starting Kubernetes community in Sri Lanka back in 2018. He is passionate about assisting the community by sharing information via media articles and speaking at community events. Hi Nilesh, the stage is yours.
Thanks Chirath. So today I'll be talking to you about securing Kubernetes. So in this session I'll be talking about from a point of view of an attacker and how an attacker might try to sabotage a cluster and how we can prevent it. So as the first slide, I'm introducing you to the area of attack when it comes to a Kubernetes cluster. And at the bottom you can see infrastructure as cloud, which is basically where you have your data centers, your firewalls, your network and servers. And the Next layer, we have our cluster where we have RBAC, authentication, authorization, then we have admission control, and we have network policies. On top of that, we have containers where we have container sandboxing, image restriction, privilege, escalation, supply chain, etc. And finally, we have developer discipline as the code base layer. So let's look at the first scenario. Attacker has access to your network. So now the attacker has somehow found a way to find your network, and now how can you prevent that? So basically, if you're using cloud, you can basically use SSH based key auth, and then you can make your Kubernetes API private to avoid these attackers or intruders discovering your API and try attacking it. And then you can have a firewall. You can secure your network through a firewall, and then you can have proper RBAC policies implemented in your cloud and also in your cluster. The next scenario is attacker has access to your Kubernetes control plane. So now the attacker has somehow gotten through your network, and now it has access to the infrastructure of your Kubernetes control plane. So before jumping into what we can do, let's just go through a few slides on how, what Kubernetes RBAC is, and what things are. So on the first slide, we have on the left, we have who can access. So in Kubernetes, we have two types, users and service accounts. Users are for humans, and users are someone with a cert and key, and the certificate is signed by the certificate authority of the cluster. Cert is managed by external to the Kubernetes. And it's not a resource in Kubernetes really, as I mentioned, it's handled externally. And then we have service accounts. So service accounts is for processors. It's not for human use, but rather when there's a pod or some other resource in Kubernetes trying to talk to the Kubernetes API, let that be a worker node, let that be a pod, CRD, whatever, they need a service account to access the API. So these are the users in a Kubernetes API. And then comes permission. So as you can see on the right hand side, we have two kinds of permissions. One in blue is called role, and the one in orange is called cluster role. So as you can see, the role is namespace bound. So when you create a role, it only affects a namespace, whereas when you create a cluster role, it's rather global in Kubernetes. It's accessed across all the namespaces in the cluster. And then to bind this role into a user or a service account, we have something called a role binding. So there are two kinds of role bindings, one being the name role binding itself, and the next one being the cluster role binding. So role binding is also namespace bound, and when you have a user, you can bind a role to that user in a given namespace, and that role can either be a role or a cluster role. But when it's a cluster role binding, it's more advanced, and it has a lot of privilege, because it doesn't scope into a namespace. It's there for the entire cluster. So when you do a cluster role binding to a certain person on a certain permission, the person can access that permission across all the namespaces in the Kubernetes cluster, which is a bit dangerous. So we'll look at an example in the next slide. Here we have John, who can do read secrets in the foo namespace, and there's a role called read secret role in foo namespace, and you can see on the slide that there's a read secret role binding to John, which gives John access to read secrets in the foo namespace. That is all right. Then there's Jane. So Jane needs access to read and write secrets to the foo namespace. However, read and write secret is a cluster role we have created for some reason, and in this scenario we can still create a role binding to the cluster role, which is read write secret, to Jane, which gives her the correct access to foo namespace. But now then look at the admin user. Admin user, we have given admin user read write secret cluster role binding, which means the admin user, as you can see from the red dotted lines, that they can read across namespaces of all the secrets that there are on the all the namespaces available in the cluster. So this can be pretty dangerous if you don't properly give access. So it's recommended that you use role bindings and roles instead of cluster role bindings. So hardening a Kubernetes cluster, we already spoke about RBAC policies and how to set it up. The next thing you got to do is enable audit logging. So when a disaster or something has happened, someone has access to your cluster, your best friend would be logs. So you need to enable audit logging to figure out who did what on your cluster, so that you can trace what has happened and come to a conclusion. The next thing is you got to run CIS benchmarks on your cluster. This is mostly applicable for the clusters that you have done from scratch on your data centers, etc., because cloud managed clusters, GKE, AKS, EKS, these already have CIS benchmark reports on them. It's managed for you, but if you are managing your own clusters, if you are managing your control planes, run CIS benchmark and do the recommendations that they have given. The next one is, this is applicable for the clusters in cloud as well, managed clusters as well. Use a CIS hardened image. So by default, when you get a GKE or AKS or EKS cluster, they provide you a simple node, a node with a Linux runtime and containerd runtime for image for containers. But you can have CIS hardened node images which has more seccomp profiles, AppArmor profiles installed, baked deep within to the node image itself, which would give you more security. The next thing is encrypt HCD. Doesn't matter whatever the security tools you run, you might be running runtime security, sandbox, you might be running everything, but if your HCD is not encrypted in your control plane, any attacker who has access to your control plane should be able to easily look at the key value store that HCD provides and then read from it and get your secrets. Same goes for your secrets. So the common recommendation is, 12-factor apps taught us to inject variables as environment variables. That's not the case anymore. Now you have to mount them as files, right? So attaching environment variables can leak your credentials to someone who has access to the VM. So don't do that. Mount your variables as a file and then read from that file. Let's go to the next section. Attacker has access to a service account in your cluster. Alright, so now attacker has come in. Now it has the control plane access, and somehow it has access to talk into your Kubernetes API with some permissions, right? So how do we stop that? First of all, let's look at network policies. The concept of network policies is, as you can see on the example here, we have a web server in green, a Python backend and a database. And as you can see, there's no need for the web server to talk to the database. Only the Python backend needs to talk to the database, and on a separate namespace we have something called a super important API. Right. By network policies, what allows us to do is we can specifically say which pod can talk to which service. Right. So we can specifically say web server cannot talk to the database, web server can only talk to the Python backend, and Python backend can talk to the database. So if somebody has exploited web server and has access to the web server, they won't be able to write directly to the database. They won't be able to access the database. And then if somebody goes and comes and gets into the Python backend, of course then they have access to the database, but still, because of network policies, they will still not be able to attack the super important API we have on a different namespace, right? So that's what network policies allow us to do. And by default, you have to use a CNI, a container networking interface plugin on Kubernetes that supports these network policies. Network policies can be at many layers. So commonly it's at TCP4, but layer 7 network policies supporting CNIs are there, such as Cilium, etc. So it's up to you to figure out which to use. Let's move into the next slide. So as I said, so for the first thing is you gotta use namespaces to isolate your tenants on the network. Then use network policies, which is the Kubernetes equivalent for firewalls. Then it's added advantage if you have an API gateway, you can even make the inter-service communication go through an API gateway. If you're using a service mesh, use MTLS. Or if you're using a service mesh that's powered by eBPF, network encryption, etc. happens by default, you can do that. So that's great. That means no one who has access to your infrastructure cannot overlook your network and figure out what's going on. Finally, there's something called admission controllers on Kubernetes. So there's open policy agent, Kivro, etc., which allows you to write policies on Kubernetes, your Kubernetes cluster, which I'll explain in a bit more in a later slide. So now, attacker has access to your code base. Now, if an attacker has access to your code base, attacker can do a lot of things. They can insert malware, they can insert vulnerabilities and exploit them later. They can do a lot. So to avoid this, you can do a few things. First one is, of course, static scanning. With your CI pipeline, you can do SonarQube scan, etc., and figure out if you are committing any sensitive information to Git, which is accessible by anyone if it's public. And then you can do code vulnerability scanning, as I mentioned. And then you have to keep scanning these. It doesn't matter, like today you scan it, it's all good, everything is green, but there could be an exploitation or a vulnerability discovered tomorrow. So you gotta scan on a daily routine or on whatever the preferred way that you do. Then goes image vulnerability scanning. So here our images might contain vulnerabilities. This also, again, you gotta scan at an interval or a duration. You can't just scan once and if it's okay, you can just forget about it, right? You gotta scan continuously. And exploiting a vulnerable image could lead to privilege escalation. Someone can get remote shell access. Your information could leak. Someone could give you a DDoS attack within the cluster. I personally use Claire, but people use Trivi and any other tool you can do to use image vulnerability scanning. And then there's another one called configuration scanning. So configuration scanning is when you're committing your YAMLs to your GitOps repository, etc., you can easily check them via Checkov or something else and see if you are missing anything, if you are missing a trick, if you are missing any configuration, security configuration or a policy. So it allows you to, it gives you feedback and you can fix them and secure your pipeline. So let's talk about Kubernetes admission controller, which I promised I'd talk in the previous slide. So let's see what it does. So in this scenario, there's a create pod request by a user. So when that request is gone to the Kubernetes API via kubectl, what happens is, firstly, it figures out who you are, right? Then it goes to the authorization. What can you do? Can you actually create a pod? Then finally, there's something called admission control. So in admission control, there are so many policies, even we can write our own policies. In this scenario, what it's going to look at is whether have had the pod limit has been reached on the given NS, whether you are able to create a pod or not. So admission control has two types. When we plug in, we have something called validating webhook and a mutating webhook. So validating webhook is a read-only type where it scans a given request and it just either allows it or denies it. This is perfect for third-party policy controllers like Open Policy Agent or something else. So here you can give any additional policies like don't pull images from public Docker, right? Pull images only from your private Docker registry. So you can give these policies and it would automatically deny at the admission control level when you give that policy via a third-party policy controller, or you can write your own validating webhook for it as well. Then there's mutating webhook. So that's a bit different. So it changes the payload dynamically. This is mostly used with CRDs and controllers that work with these operators that CRDs. So here You give a payload, and according to some logic, it changes the payload dynamically and applies to Kubernetes in a different manner. Right? So that's what Kubernetes admission controller does, and this would allow you to write your policies and secure your cluster. Right. The next step is now the attacker has access to your container. Somehow they have exploited your container. Now they have a shell. They have a shell access, and now let's see what we can do. So when it comes to container hardening, when you're building the container itself, there are some best practices that you got to follow. First thing is remove the bash shell, right? So that they won't be able to access your shell remotely. Make the file system read-only so that they won't be downloading anything or writing anything into your container file system. And then make sure the user is running as a non-root user. So when these are done, it's hard for us to, for an attacker to attack and exploit a container. So basically make your container immutable. Then there are other things that we can do. There are images which we don't have access to, to change the image, right? There are scenarios like we don't build the image, somebody else built it, we only run it. So in those scenarios, we can use Kubernetes without changing image to enforce immutability. So we can run there's this thing called startup probe in Kubernetes, where a container is running. You can run some script before the container actually starts running. Using that, we can remove bash if we want to, and we can set like run as group, run as user, run as non-root, set security context, remove privilege escalation. Can do a lot of things. So by using those, we should be able to make the containers immutable at a Kubernetes level as well. Then comes runtime security. Doing all of that is sometimes not enough, and you need more. Let's look at how containers work and what this runtime security means, right? So as you can see in a VM, when a container is running, it's running at LXC, on top of LXC, and then we have Linux kernel at the below, right? So basically a container is a group of namespaces and C groups. So when containers are making this doing things, it does syscalls to the Linux kernel. So say that means if there's a vulnerability in the Linux kernel, the container should be able to exploit it if someone with the proper knowledge and tools are there. So first thing to do is, as I mentioned earlier, disable privilege escalation and drop all the capabilities of a container, and then only add the things that are needed using Kubernetes constructs. And there are things like AppArmor and seccomp profiles, which restricts the syscalls that you make to the Linux kernel, so that you don't make any weird ones and try to exploit your kernel. Then there's container sandboxing. There's Firecracker, there's gvisor. There are a few out there, which is makes this issue go away, but on top of it adds more performance issues. But still, it's great if you're running a multi-tenant system and if you don't trust the images. Then there are tools like Sysdig, Falco, etc., which monitors the anomalies of the container runtime and then gives you alerts like this is happening, stop this, etc. Right? So that's container runtime security for you. So you gotta conceal your information. This is something I told earlier as well. I asked you to do not inject environment variables, but rather do them as file mounts. And when you're doing that, it is recommended to inject via secret manager at runtime. Don't save it as secrets on Kubernetes itself. Base 64 is not an encryption. So use HashiCorp Vault or Azure KV, AWS, Google. There are so many secret managers out there. Use one of them and then inject your information, sensitive information, as files to the container at runtime. You can very easily do that with those technologies. And I already told, make your container root the system read only, and this is a developer discipline. Do not lock sensitive information. So comes to the final thoughts. Kubernetes security is still new, and vulnerabilities get discovered every day and then they get patched frequently. So update your clusters as soon as you could. If you're running your own or even in cloud, just keep upgrading your clusters. When it comes to managed Kubernetes clusters in the cloud, security is mostly, 70% of security, control plane security, it's managed. You don't have to do much there. And many organizations today need some level of multi-tenancy. They might have different teams, etc., working different projects and within a shared Kubernetes cluster. So these could be, these things that I told in this slide, in this session, would be appropriate if you can implement them in these scenarios. So, keep the proper standards up and follow up, and things should be all right. That's it from me today. Thank you, and I hope you learned something today. Over to you, Chirag.
That was awesome, Nilesh, and thank you for the great session about Kubernetes security. Now, let's move to our next session. We all know cloud-native applications frequently run in containers as part of distributed microservice architecture. Kubernetes deployments have become the de facto standard for the orchestration of these containerized applications. And also, we all know that the distributed applications in any architectural environment, including the cloud, have always required rules to control how their requests get from place to place. It means we need a tool that inserts security, observability, and reliability features to the applications at the platform layer instead of the application layer. That tool needs to be sustainable and demands less operational burden. As the engineers, at the end of the day, you folks need to handle it, right? And this should be a scalable tool. That's where the service mesh comes into the stage. Now, we are going to see service mesh in action with Linkerd, the graduated CNCF service mesh that makes the fundamental tools for software security and reliability freely available to every engineer in the world. We have Flynn, technology evangelist from Bryant, who works on spreading the good word about Linkerd and Kubernetes and cloud native development in general. He is also the original author of Emissary English API Gateway. Hi Flynn, the stage is yours.
Hi there, my name is Flynn. I am a tech evangelist for Buoyant, the makers of Linkerd. If you're not already familiar with Linkerd, it's the only CNCF graduated service mesh. Linkerd's purpose in life is to arrange it so that every cloud-native developer on the planet has access to the tools that they need to do secure, reliable, easily observable cloud-native applications, and for those tools to be freely available. My role as a tech evangelist is to make sure that people know that, and also to make sure that people have the knowledge and resources that they need to really succeed at the whole cloud-native thing. So to that end, today I will be talking about observability using Linkerd. This is kind of the classic problem in cloud native. It's very, very hard to really see what's going on inside the cluster, even when things are going well. When things start going badly, it's even harder. Service meshes are well positioned to help with that, and for Linkerd, there are two things in particular that make it really good at it. One is this Linkerd Viz tool, the other is the Service Profile CRD. Linkerd Viz is a tool that just gives you easy access visually to a bunch of things within your cluster. Here we can see the topology of our application, we can see a bunch of statistics, success, requests per second. There's a bunch of stuff in there. We'll look at some of that as we go on through this presentation. The service profile, on the other hand, is a CRD that first defines kind of how Linkerd should be watching your application, and it also gives you access to ways in which Linkerd can help manage your application too. So for example, if a delete request comes in matching this URL over there, then that will get bundled up as a statistic into this bucket with a much more human readable name, and all of the deletion requests, no matter what ID they are, go into the same bucket to make it really easy as a human to figure out, okay, are deletions working or are they broken? Also, the really killer bit of this is that as soon as the service profile is created, Linkerd will watch that and it'll aggregate statistics for you on its own without you having to do anything special. You'll be able to go through and look back in time to get access to those. It's a really, really wonderful tool for troubleshooting. Also, I said management. So for example, you can use a service profile to do things like configure retries automatically. We're going to see some of that with the rest of the demo here. And yeah, this is pretty much it for the slides. The rest of this presentation is a live demo. So yeah, let's get to it, shall we? Okay, so I have here a running Kubernetes cluster. I'm doing all this on a K3D cluster that's running in my laptop just because I kind of like having control over everything. The first thing that you'll see here is we've got the books demo and we have the emoji vote demo. So we have both of those running in the cluster. We can take a look. This is the books demo. You may have seen it before. You can, you know, go click around and look at books and look at authors, and yeah, it's pretty simple. This is the emoji vote application where you can go and vote for emoji, and then you can view the leaderboard, and that's all there is to it. I should point out there is a traffic generator in here. I am not just clicking endlessly on emoji all day. So let's go back here. We also had Linkerd running, and you know, I've got an Ingress running in the cluster as well. That's kind of, I just like to be able to use domain names instead of having to do everything via port forwards, and then I misremember the port. All of this I pretty much set up just using the quick starts available from the Linkerd documentation. I'll have the link at the end of this presentation where you can go and see exactly how I set everything up. It's pretty standard, pretty easy to get going. Very important thing here is that you have run Linkerd check. We can see that Linkerd is actually running cleanly on its own, so we're good to go. All right, now let's suppose it's Friday night and somebody calls up and says something is wrong with the emoji vote application. They don't know what's wrong, they just know something is wrong, it's not behaving. What should we do about this? Well, I guess the first thing we can do is we can just look over all the namespaces in the cluster using Linkerd viz from the command line. And we can see immediately that, yeah, there's some challenging stuff here. The emoji vote application actually is not showing us 100% success. Neither is books, but we'll have to come back to that. So given that we can see that there's something wrong in this namespace, let's drill into that a little bit. Here we're going to look just at deployments in the emoji vote namespace, because that's where we already know that there is a problem anyway. So if we do that, again, we can immediately see that the web deployment and the voting deployment look like there's some kind of unhappy things going on. So those also seem like pretty natural places to look. So we're going to go ahead and take a look at the web deployment. We'll use Linkerd viz top for this. That's going to give us a rundown in real time of the most common requests that are going to or from the web deployment. If we do that, we can go through and we can see a bunch of things happening. But it's most interesting, I think, to look over at the success rate column here, which is all 100%. So far, this is working out okay. Wait a minute. That's not a good sign. Okay, so that tells us that at least this time, voting for a donut did not work. And it looks like it might not be working at all, come to think of it. So that's something where it looks like the web deployment is talking to the voting deployment. So maybe we should go take a look at that. Let's go ahead and take a look at the voting deployment. If we look at the voting deployment with Linkerd viz top, then let's see, things up. Nope, that's not working. Yeah, it looks like we have a problem with voting for donuts. That's too bad. Donuts are usually pretty popular. At this point, we probably could go off and hand this off to the developers and say, hey, it looks like there's a problem voting for donuts, but we can probably do better than that. So another thing we can do is, instead of running Linkerd viz top, we'll run Linkerd viz tap. Tap shows us real-time, request by request. It just gives us a running list of everything going on. It's a really nice way to get a quick look at the actual real live traffic. And here I see a bunch of things that are working, right? I see a post, it gets to 200, it's got a gRPC status of okay. So far, so good. I don't actually see any donut requests so far. Oh wait, here's one, all the way down at the bottom. Yeah, so you'll notice that this says gRPC status unknown. Very important to note here. Status unknown does not mean that Linkerd doesn't know what the status is. That is a gRPC error message that says something went wrong and the gRPC layer can't tell us more about what happened. but we know that something is wrong here. So that means we can come back. Maybe we should just drill into the voting for a donut, only that one, right? If we do this, and we might have to wait a little bit for somebody to actually vote for a donut. But if we do this, we should be able to see whether, is voting for a donut always failing, or is it only failing part of the time? Looks like it's always failing. Okay, all of these are saying gRPC status unknown. That definitely gives us enough to go back to the devs with. We could go back and say, hey, we're seeing a gRPC error when you vote for a donut. But we can now say we know it's a gRPC error. Is there anything else we can do here? There's one more thing. If we tack -o JSON onto that same command, so we're going to look at the donuts, but we're going to look at it in JSON, then instead of giving us that nice 3-line summary, it'll break everything out into a huge JSON block, and we'll get information on the requests and the responses. There we go, there's one. So we can see this is a request. It's going from the web deployment to the voting deployment. It is, in fact, a vote for a donut. If we scroll down, we'll be able to see the response. So we come down here, there's the response. And if we scroll a bit further down, we can see, oh yeah, look, gRPC status 2. If everything were working, that would be gRPC status 0. We don't really get anything particularly useful in the error message, but at least we can now go back to the developers and say, right, when you try to vote for a donut, you get a gRPC status of 2, that's a problem. So overall, that works out pretty well. On the other hand, this took a little while. And the reason that it took a little while was that we needed to go through and watch the traffic and wait for somebody to vote for a donut so we could see the problem. Then we had to wait for them to do it again so we could see if the problem persisted. There should be a better way. And as I was mentioning earlier, with service profiles, there is a better way. The emoji vote application is a gRPC application. gRPC means protobuf. Protobuf means that rather than writing service profiles by hand, we can just ask Linkerd profile to go through, read the protobuf definition, and write us a service profile for it. So let's do that for the emoji proto. There you go. There's not much to it. It's both posts, which is kind of interesting. You can list all the emojis. You can find a given emoji by shortcode. That's kind of it. If we needed to modify this, we could, but this is certainly a great way to get started at minimum. So let's go ahead and apply that to the cluster. And same command, right? Just generate the proto and then apply it. That works out pretty well. And then we can do the same thing for the other gRPC that's part of the emoji vote application, the voting proto. I'm not going to bother showing that. It's pretty much just more of the same. So we'll apply that one. Now, we really want to see some things about the web too, and that's problematic because the web app here is not gRPC. The web app is just plain old REST. So we could write the service profile by hand. If we had a Swagger definition, we could have Linkerd profile just read the Swagger definition and write a profile for us. In this case, we don't have either of those things. So instead, what we're going to do is this other trick where we can have Linkerd just watch the traffic going by for a little while. In this case, we're going to say 10 seconds and generate the profile based on what it actually sees in the traffic, which is kind of cool. So let's go ahead and do that. And it's going to take a few seconds here, of course, because I told it 10 seconds. Let's take a look at that profile that it wrote. And yeah, you can see lists, you can see votes. It's pretty straightforward, right? So let's go ahead and apply that. And now we should be set up to debug this problem with emoji vote much more quickly than we otherwise would have. So now we're going to go check this out by looking at the dashboard. So here we are at the dashboard. We have the Books app namespace, the emoji vote namespace, and as we saw from the command line, things are not working flawlessly here. Let's go into this namespace. And you can see with the topology graph, we've got this vote bot that's generating traffic, sending it over to the web service. The web service in turn is talking to the emoji service and the voting service. All this lines up with what we saw from the command line, which is kind of nice. Let's go take a look at the web deployment itself. And you'll also see a different graph here of which deployments are talking to which. But the really neat thing we can do now is we can click on this route metrics tab, where we can just immediately see, oh, hey, here's the route that's not doing so well. Get API vote. If we go over to the voting deployment in turn, then we can scroll down and check out its route metrics. Here, let's just sort by success rate, and we can instantly see, without waiting for anything, that yeah, it's the donut that's causing us problems. If we want to drill into that, let's go back to the live calls here. And we can click on the microscope for any of these. Let's see if we get a donut. Yep, there's a donut. Great. It moved up because this is a top view. Let's click on that. That fills in a tap page for us. You can see it filled it in with donut. Click on start. As requests for donuts come in, then this will populate here. There's one. And we can click on this tab, and there you go. There's the JSON view from before. So we kind of get to have it both ways. Obviously, this is much faster than going through and running all the stuff from the command line. But important to note, it's working on exactly the same information. So everything you can do here, you can do from the command line. All right. So at this point, we would hand this over to our developers, tell them that there's a problem with the donuts. We can go on, and of course, that would be the time that something comes up with the Books app, because, I don't know, that's the way life goes, right? Now, the nice thing about the Books app is that the Books app already has service profiles, so we don't have to go through and build them manually. So we can go straight to the route metrics from the command line and see, okay, what's going on with the web app service here in the Books app. And we can immediately see that, oh, right, there's two things in here that seem to be failing about half the time. That looks, problematic. We can also go through and do the same trick we did before, where we drill down and say, okay, show me where the web app's deployment is talking to the author's service. How is that going? And you can see there's a little bit more detail here. There are calls in this list that don't show up here, but in particular, we can also note for our debugging purposes, all of these are working, so there's probably nothing for us to worry about there. Let's check the web app talking to the Books service. And what do we see there? There we see, okay, here we've got a couple of things that are failing about half the time. That's probably not good. Finally, up here, we're not going to see traffic between the Books service and the author's service, although maybe there is some. So let's take a look at that. And what do we see? Yeah, there's one call. It's just a head call, but it's failing about half the time. Kind of interesting. Now, we could of course do all of this from the GUI as well. Let's go ahead and do that. We'll back up to namespaces, then duck into the Book Apps namespace. There's our topology graph again. We saw this at the beginning of the presentation. Traffic generator talking to the web app, talking to the Books app, talking to authors, and books and authors are talking to each other. So here, if we go through and take a look at one of these, let's look at the web app, shall we? Once again, we get the neat little graph here. And once again, we can go down and look at route metrics and kind of immediately see, right, so these are a problem. If we go in and we look at, let's look at the author's deployment actually. If we look at the author's deployment and we look at its route metrics, then again, we can immediately see, okay, this head, that's got some trouble, right? So, an interesting thing here, head requests are idempotent. They have no data. They make a great candidate for retries. And service profiles, if you'll remember, are a place where we can configure retries. Here's the service profile docs, configure retries on your own services. If we look over here, routes that are idempotent and don't have bodies, you can edit the service profile and add is retriable to the retriable route. That's the only thing we have to do to enable retries happening down in the mesh. We don't have to change any application code. So let's go ahead and try that out. We will do that using kubectl edit. We'll do that the really simple way. That's the author's service profile. All the way at the bottom, you can see this is the head that we're talking about retrying. And we are literally going to just add is retriable true. Then we'll save that, quit, that's updated. And now let's go and watch and see what happens. If we tack -O wide on this Linkerd routes, it will tell us the effective success rate as well as the actual success rate. And if this worked, we should see these two start to diverge. We should see that the effective success rate will be going up, even though the actual success rate isn't doing much. And yeah, we can see that it is going up, in fact. That, here we see 62% almost. Let's give it another few seconds here. 68%. Yeah, so that looks like it's headed in the right direction. What we don't know yet is whether this is the only problem with our books application right now. So let's go take a look and see from, what shall we do? Let's look from the web apps point of view, I think. Yeah, web apps talking to books, that'll probably do this. And here we can see, right, so we've hit 100% on everything at this point. And here we're only seeing the effective success rate, but the effective success rate is the one that we care about from the user's point of view. So at this point, we've been able to use Linkerd to figure out what was failing and to put in a mitigation so that the end user is no longer affected by this problem. We still have work to do with the developers, obviously. We're going to have to go through, figure out why exactly the thing was failing, which we don't know right now. And we're going to have to, get a fix put in place to really solve the problem for real. But if you remember, I started this by saying it was a Friday night, and putting in this quick change to the service mesh means that we don't have to go back and bug the developers on Friday night. Everything is working from the user's point of view. We can come back and tackle this in the morning on Monday. So that's about it for this demo. You can find more information about Linkerd at linkerd.io, or you're always welcome to join our Slack. Go to slack.linkerd.io for that. Hope you do. The source code for Linkerd is in the github.com Linkerd organization. You can also find us at Linkerd on Twitter. If you're curious about how this particular demo got set up and run, you can look in the Service Mesh Academy repo. You'll find everything there, all the details. And you can always reach me at flynn@buoyant.io for email, or at Flynn on the Linkerd Slack. Hope to hear from you. Thanks.
Thank you, Flynn. Yeah, we hope you got best practices Flynn showed to while working with Service Mesh in action with Linkerd. We know developers love to use VS Code as our coding editor. In 2021 developers survey, Visual Studio Code continued to be #1 ranked with 70% of the 82,000 respondents using it as their coding editor. So today, we will showcase how VS Code and Azure involvement of Kubernetes and cloud development. To showcase this session, Vito is the best person who can deal with Azure and Kubernetes. Vito is a senior cloud solution architect at Microsoft. He's been developing applications for 27 years and a big fan of Azure, GitHub and Visual Studio Code. And Microsoft is our platinum sponsor of KCD SL. Vito, stage is yours.
Hey everyone, my name is Vito Chin and I'm here today to show you some of the practical advantages of using Visual Studio Code and Azure for Kubernetes and cloud development. So let me start by introducing myself. I'm a senior cloud solution architect at Microsoft. I've been here for almost 6 years and my focus area is digital and application innovation. I've been a programmer for 27 years. Started from C to Java to PHP to Objective-C to Node.js. You can find me on Twitter at VITOC. Now, at Microsoft, our mission is to empower every person and every organization on the planet to achieve more. In today's session, we'll start our journey from Visual Studio Code. Then we'll make our way onto GitHub, and finally to Azure with Kubernetes. Let's start by setting up ourselves for success with Visual Studio Code. There's a few extensions that I'll use in this session, and I'll recommend that you install them as well, as it is really good for ease of development. The first one is Azure account to sign in to our Azure subscription from Visual Studio Code. The second one is Azure Container Apps. The third one is Code Spaces. And lastly, GitHub Copilot. You can look for extensions easily by looking for the right publisher. In this case, we want to look for publisher Microsoft. And you get to all of the Microsoft related extensions for Visual Studio Code that you may want to install. For Azure related extensions, you can go for category, which is this category Azure. So this, you get to all of the Azure related extensions. Okay, before we go any further, please allow me to introduce you to GitHub Code Spaces. Now, developer environments are where developers do their work, but local dev environments have problems. Let's take a look at some of the challenges that developers face coming to a new project. So the first thing we do is we set up the environment, and this requires resolving the dependencies that will be needed in that environment in our local machine. So this takes time and is also very expensive. If you look at the kind of software that we need to run, it's kind of like emulating the server, right? So we need a powerful machine, so it's expensive. The third thing is security. There's a couple of issues here, right? The one thing is that your machine can be vulnerable to, say, malware, and your code that's actually residing on your machine may be copied or exposed. So the other thing is your security team can't really review code that's on your machine. So that's from a security point of view. From a collaboration point of view as well, there's also challenges. Today, it takes a huge amount of time for someone to drop in and make a fix to a project because of the environment that's required to first set it up in the first place. Lastly, talent, right? We don't want people to be spending their time troubleshooting the correct versions and all of that, right? We want talents to be, we want your talent to be used where it's best to really code things that matters. So here's some of the runs that we hear from developers and their environments. So we lost a whole day getting a QA engineer running on that project. We have a virtual desktop solution for contractors, but it's very hard to use. Running multiple Docker containers on our company-issued laptops gets tricky. Inconsistent local environments are making it hard to standardize on build tools. Hence, CodeSpaces to the rescue. CodeSpaces is a cloud development environment that lets you code from anywhere on any device. CodeSpaces does this by running code and dependencies in a VM on Azure. The development environment, whether that's Visual Studio Code, Visual Studio, or in-browser VS Code, connects there. Let's have a look at CodeSpaces. This is the sample app that I forked from Azure samples that I will use for this session. The reason we fork the code is to make changes further down the road. With that, we can now start our code spaces. So we'll create a code space based on the main branch of this repository. And it'll take a little bit of time, not too long. Okay, it indicates that the image had been found and the container to run the development environment had been built. Okay, now that's the code spaces started. The code space that we started, as we've just seen, lives within a browser. We can also connect to a code space through a Visual Studio Code client as well. The code remains on the cloud. The idea is to be able to develop from anywhere, and that can mean in a remote location or from any particular device, or from a laptop that's more of a dumb client rather than something that's fully configured. That is really about providing the premier developer experience in a flexible way. The other idea is developer velocity. You can't achieve this in any other way. With a code space, a developer has an environment ready to go that they can pick up right away. Switching between tabs to go between projects instead of spending literally hours to spin down one project and then spin up another one. And onboarding and training will go much faster as well. Codespaces also allows secure development from any device. You can revoke access at any time, knowing that revocation truly results in loss of access to protected resources. Codespaces code stays in your container, which means you can worry less about data exfiltration, and also enables collaboration in zero trust scenarios, like quickly adding contract resources to your team by ensuring that code remains in cloud resources that you control. When people can work with code immediately without environment setup and those kind of stuff, amazing things happen. Security and ops can start interacting immediately and understand the effect of changes. Inner source also really starts to happen. Personally, as a developer, I'm a minimalist. I don't like having a lot of stuff on my laptop, right? It slows down the computer, it takes up memory, right? So what happens is with Codespaces, all of these are actually on the cloud, and it frees up those resources on my local laptop, and it's super fast. So that's one advantage that you get as a developer. The next thing is the storage and compute. It actually scales up on demand. So that's the other perk that you get using Codespaces. Coming back to our code space, remember earlier I mentioned that we will need to modify the code more. So here I'm noticing that there is no dev container definition. So dev container.json allows us to be more precise with the kind of development environment that we want. So here I'm noticing that we do not have Docker extension or Azure Container Apps extension installed. So let's go about getting that into our dev container. So we start by looking for Docker. So instead of installing it like this, what we want to do is right click and add it to our dev container. So by having this dev container, it will not just benefit us, it will benefit other developers as well, as they will definitely need to have these kind of extensions working at their code space as well. So here there's no container configuration currently found, so I'll add one, and let's add one that's based on Node.js. Let's do for the default one. And we'll need Docker as well, so let's go for Docker from Docker. Let's reuse the host Docker engine, and we'll look for, go for the latest one. And there we go, we have a dev container.json now. Let's look here. Right, cool. Within the dev container.json definition, we will now see that the Docker extension had been added to the list of extensions. These are the extensions that will be automatically added when we turn on our code space the next time. And we have Docker from Docker as a feature as well. Now let's commit our code and see how it can benefit the next developer. So let's add to git and commit and push. Okay, so let's have a look at how the next developer can then see this extension already added when they turn on a new code spaces based on this repository. Let's go to the repo over here. Okay, so let's turn on a new code space. So notice that there's already 2 code space. So I'm going to create a new one. So again, it's going to build the container again. Okay, let's view logs just to see. See, notice it takes a little bit longer. It's setting up the necessary Docker, and okay, now it's done. Yeah, container started. Okay, now it's saying that Docker from Docker is not a v2 feature. Okay. Okay, so now this is a new code spaces, but it's actually turned on based on our newer code with dev container added. So this is the dev container file, right? So let's see if we have our magic here, which is the Docker extension installed. Yay! So yeah, so the next developer, imagine, will then save a step by having this extension already there. Remember seeing the notification on Docker from Docker earlier while turning on the code space? Right, let's find out what's that about. We can do that with the creation log, and we can access it from the command palette. Let's go to creation log. Yeah, so this is the creation log, and let's head to Docker from Docker. Yeah, so let's get a detailed view. So feature Docker from Docker is not a v2 feature, attempting fallback to v1. Yeah, that's fine for our purposes. Okay, now the next thing we should do is to build our application. Let's look for our Docker file, which is the source Docker file, which is this one. Okay, and we build a image in our dev environment here. So yeah, that is fine. Probably a little bit of a wait here. Let's load this up. Okay, that's fast enough. Now we can turn on our containers. Let's bring up the Docker extension. Yep, and this is the image. Let's run. And we have our container. Now let's have a look at our API. Let's open it in browser. Yeah, as you can see, Visual Studio Code will set up the port forwarding as well, and the authentication as well if you run it through Visual Studio Code. And there you have it, our API. Okay, now that we have looked at how we can have a development environment on the cloud with GitHub Codespaces, let's have a think around how we can then deploy our app our microservice, our API to the cloud. And here we know that we have a Docker file, which is a containerized application. So we have this here, the entire Azure Containers portfolio. So AKS and Azure Red Hat OpenShift, those provide full access to the Kubernetes layer, right? So the cluster in itself, you can control the ingress, you can control networking, you can control maintenance and scale. On the right hand side, you have Azure Container Instances. So it's a way to launch container with hypervisor isolation. So container as a unit in itself in Azure. In that sense, it's a low-level compute, kind of like your VM, and also kind of like the local container runtime called Docker Desktop, right? So it's useful in some ways, and one of the ways is as virtual nodes as part of Azure Kubernetes service, right? So here in the middle, the new thing is where things become really interesting. So Azure Container Apps, right? So this is something that we truly want to consider for our application. So if you look at the application that we just brought up on GitHub Codespaces, right? It's a microservice application. So what is Azure Container Apps? Azure Container Apps operates on top of the Kubernetes cluster. Okay, so it's on top of the Kubernetes cluster, but it's entirely managed. The whole cluster is managed, so you don't have to worry about managing the cluster yourself, right? So it's actually very interesting for those that are focused on application delivery, right? And you want to focus on really iterating on your features and all of that, right? And not on maintaining clusters, right? So the scaling, the HTTP routing, and service discovery, all those are still there for you in Azure Container Apps. So yeah, it's a very interesting service. We'll deep dive on it very shortly. But let's now take a look at the bottom right? So we have Azure App Service and Azure Functions. Azure App Service, it's a way to host web apps and web APIs. You can publish code directly to it, and you don't have to manage a container. And it has cool features like deployment slots and all that, right? But if you compare Azure App Service to Azure Container Apps, right? Azure Container Apps is actually more optimized for microservice that needs to communicate to each other, right? So Azure Container Apps is more suitable if you are looking at developing microservices. Lastly, we also have Azure Functions, right? Okay, so Azure Functions is serverless. The thing about Azure Functions is that you need to interface with it with Functions SDK, right? So it's a little bit more opinionated. But on the other hand, Azure Container Apps allows for any containerized app, right, to execute while still being triggered by the same model, the serverless model, using events, right? So yeah, there you go. That's all the overview of the Azure Containers portfolio, right? Now, for our app and for today's session, we'll deep dive into Azure Container Apps as the balance option here. So Azure Container Apps is the latest container offering from Microsoft that wraps around Kubernetes, KDA, Dapr, and Envoy to provide you with a serverless way on top of a Kubernetes cluster. So the serverless part is interesting, right? So you get serverless level pricing and a Kubernetes cluster on top of it. So serverless containers, how does that even work? In short, KDA. Kubernetes event-driven autoscaling. With Azure Container Apps, you can run containers and scale in response to HTTP traffic. It also supports a growing list of KCD supported scale triggers like Azure Event Hub, Kafka, RabbitMQ, MongoDB, MySQL, and PostgreSQL. With this, you can scale to zero and pay for only what you use by the second. Anyway, this session is about showing you the practical advantages of Azure for Kubernetes and cloud development. Azure Container Apps is another example of the kind of advantage that you get on the Azure cloud. Because you're not burdened by managing a container orchestrator, you get more time to focus on building your app. With container apps, you can build microservices, APIs, event processing workers, and background jobs using containers. You can use any programming language or framework, and there's even built-in Dapper integration that gives you a given path to simplify common tasks like event processing, PubSub, and service invocation. Lastly, you can set up code-to-cloud pipeline using GitHub Actions. Container Apps is built on great open source technology. Kubernetes, KCD, Dapper, Envoy, all these are open source. You have the assurance of being able to create modern apps with open standards based on a Kubernetes foundation and portability in mind. With container apps, you can rely on streamlined application lifecycle tasks such as application upgrades and versioning, traffic shifting, service discovery, and monitoring, all on open source. Now let's go ahead and deploy our app to container apps. Here we need to install a couple more extensions as we mentioned earlier. So let's install Azure Container Apps. Okay, if we install this, it should pull in a couple more dependent extensions that we'll need. Right, cool, that's done. Let's have a look again. Okay, cool. So with Azure Container Apps installed, we can then proceed to deploy our app. Let's make this bigger. Oops. Okay, so first thing we do is sign into Azure. Let's go here and sign in. Okay, we'll need a container registry to hold our image, so let's create one. Registry and create registry. Azure, let's give it name. Basic one will do. And let's create a new resource group here. And let's have it here. Okay, cool. So yeah, so we are doing this within Visual Studio Code. So we are doing all of this within just this environment, right? Okay, so now we have successfully created the registry. We will now be able to see our registry from here. Okay, so vdemo rack. Let's tag our image for deployment. Go here, tag, so that we know where it's going to. Let's give it a simple name, and yeah. Okay, now we can push. Click, push. Right, that's okay. And we'll begin pushing. Okay, almost there. Right, done. You will be able to see our image here. There you go. Next, we'll need to create a container apps environment. So we'll go here, and yeah, from here we can see that I already have one environment, but let's create a new one for demo purposes. So we'll create a new container environment, and I'll call it vdemo env. Okay. So it's creating here at the bottom. And notice here that we're still on Visual Studio Code. Okay, almost done. And we're done. So with a container apps environment, we can now proceed to create a container app. So create container app. We'll call it vdemo app. Then we'll get the image from the registry that we've created. Okay, it's getting the repositories. Yep, this is the one. We should get the tag that we want. We'll skip this for now. Yes. Okay, once our demo app is up, we can then take a look at our API on the cloud. Let's just browse here. Open it up, and there you go, we have API. Earlier you saw that we created a container app environment first. So this is what an environment is. Environments define an isolation and observability boundary around a collection of container apps and is deployed in the same virtual network. So this is useful for situations where you are managing related services. So the container apps can talk to one another. So for example, in situations where you're using Dapper, this is also very useful. Now, if you need container apps to be isolated, then you need to create a separate container apps environment. The next interesting aspect of Azure Container Apps is GitHub integration. If you use Azure Container Apps, you should use GitHub Actions to publish revisions to your container app. As commits are pushed to your GitHub repo, a GitHub action is triggered which updates the container image in the container registry. Once the container is updated in the registry, Azure Container Apps then creates a new revision based on the updated container image. Now let's have a look at revision. Revisions are immutable version snapshots of a container app. So revisions are very useful when you enable ingress. So what you can do is you can use direction strategies like A/B testing and blue-green development. So yeah, that's revision for you. With Envoy, you can actually direct traffic to specific revisions. Say in this case 80% to revision 1 and 20% to revision 2. Azure Container Apps also gathers a broad set of data about your container app and stores it using log analytics. You can then use the Azure CLI or Azure Portal to run queries against your log analytics workspace and visualize the result. Dapper also fully comes alive in Azure Container Apps. Azure Container Apps offers a fully managed version of the Dapper APIs. So with Dapper in Azure Container Apps, Sidecar can be enabled to run next to your app instances, and this provides a rich set of capabilities and productivity gains. Here we see a service-to-service invocation between two container apps. You can learn more about Azure Container Apps or try it yourself at azure.com. Now, before I go, I just want to talk a little bit about how the future will be defined by accelerating innovation. Today, we talked about our latest innovation on cloud native and open source and shared exciting news about the next generation of containers and serverless apps that empower every developer to take advantage of flexible choices to create microservices applications on Azure. Can't wait to see what you build.
Thank you, Vito. Yeah, that was a great demonstration about how Kubernetes work together with Azure and VS Code on our production requirements. Observability is really important for us to get control over complex systems. Monitoring CPU, memory, database and networking condition is usually enough to understand these systems and apply proper solution to the problem. So, to share the knowledge of a high-level overview of how Kubernetes observability helps us to get the right direction. Here's Janaka, who is the director of Ascension IT. He is a seasoned person in the open source ecosystem, going back to days of building Sahana project at Lanka Software Foundation. He is passionate about sharing the knowledge and experience with the community. Janaka, stage is yours.
Thank you, Kavisha. Hi everybody. Kubernetes is a unique beast which consists of a multi-layered web of resources and services. Achieving observability is a daunting task, even for the best and brightest among us. This presentation will give you a high-level overview and some implementation approaches to achieve observability in Kubernetes. So let's first look into what is observability. To understand observability, the observability as well as monitoring is used interchangeably, although there's a subtle difference between them. While observability actually talks about the ability of internal to assess the internal system state based on the data it provides, monitoring deals with the collection and analysis of data pulled from the infrastructure. So observability will help you to gain deeper insight to health and status of different applications and resources across infrastructure. This helps to proactively detect abnormalities, analyze issues and resolve them. So the three pillars of observability are logs, metrics and traces. I will discuss that in later. Let's move into the monitoring. So the foundation of observability is monitoring, which involves pulling and analyzing data from your infrastructure. So it started with SNMP, the simple network protocol, since back in 1988, where we used to get information about the network, say for example like every 10 seconds or 30 seconds. Now there are much more newer protocols available, such as the OpenConfig, gRPC network management interface protocol that can provide much more real-time information. Okay, telemetry and APM, application performance monitoring, also a type of monitoring. It's a bit advanced type of monitoring. Especially telemetry focuses on collecting information from distributed system, while the APM focuses on more application level. Let's look at what are the different types of levels of Kubernetes monitoring. So there are two types of Kubernetes monitoring available, two levels of Kubernetes monitoring available. One is the cluster level, which focuses on the node information, the pod information, and the cluster resource level utilization. And the pod level focuses more on the container level, especially on the application as well as the container level information. Okay, let's see why this monitoring is so important. So in cloud native or microservices, apps are very complex and you got a lot of moving parts. When an issue occurs, it's very difficult to pinpoint and identify the issue. So monitoring is important for reliability as well as troubleshooting. Secondly, knowing your infrastructure will help you to optimize your hardware. Thirdly, public cloud, if you are using a public cloud infrastructure, you will play the cost will play a major role. So having insights into the Kubernetes environment will help you to reduce the cloud spending. Some instances, you may be using Kubernetes in a multi-tenanted, or you are providing it to your internal customers. So in that case, having insights will help you to charge back or show back to your internal customers. Finally, observability is actually a cornerstone for your security strategy. So you will be able to identify any malicious ingress and egress traffic or any unwanted pods and services that is running in your environment. Alright, so there are some challenges that comes through with this observability as well. So one is the amount of data. So you get data from your nodes, you get data from your pods, the flow data, so much of data that you have to manage. And secondly, you also have difficulty because it's a distributed system. You have so many moving parts. Getting this full picture also is a bit of a challenge that you will face as well. Finally, you will, because Kubernetes is a declarative in nature, you can actually define how you want the pods to run and create it. So that actually might give a false positive, especially when it comes to performance. Alright, so the best practices. When it comes to best practices, firstly, the granular resources like the CPU, memory, load, those things are very important but can be very complex and convoluted. So to easily identify the microservice issue, the API metrics are the main part. So what you can use is like the request rate, the call error, latency. That will help you to quickly identify the degrading components in your microservice. Another aspect is the high disk usage. So that's a very common issue that you will come across. So there's no like a straight away magical solution. You just make sure, when it hits about 70 to 80% of your storage, notify it, take some actions, right? So even though the user experience, end user experience is not built into Kubernetes, it's also very important and a best practice to understand and monitor end users experience and address issues so that the end user can provide you positive feedback as well. And if you are running in public cloud, you have to make sure you adhere to the best practices of the cloud in terms of access and identity, cost, network performance, etc. Alright, let's get back to the 3 pillars of observability. As I mentioned, it's very important when you create and implement your observability for Kubernetes. So for the first pillar is the logs. The log, basically a log is a representation of a discrete event. In most cases, it describes what will happen with your service. Log will produce in multiple ways in Kubernetes especially. So you will have cluster related log, you will have pod related logs, you will have application related logs, network and all that. So you have to have a mechanism to collect all these logs and push it to a central analytic server. Second pillar is a metrics. So metrics is a numerical representation of data measured over a period of time. Say for example, how many 200 requests did I get in last 30 seconds? And the last one is the tracing. Tracing is a mechanism that will help you to track end-to-end and identify. So your whole transaction you can manage you can track it end-to-end and identify, troubleshoot the issue. Alright, so let's look at a sample of purpose-built observability platform for Kubernetes. So this one, we have 3 layers. So the first layer is the telemetry collection. So this is where you collect various flows and different data. And the second layer will give you the analytic and visibility, where the different analysis can be performed. So you could even put some machine learn anomaly detection, and finally on the security and troubleshooting layer. Tools for implementing Kubernetes observability includes, first, at the bare minimum, you can have Kubernetes dashboard. Kubernetes dashboard will give you a bare minimum information about the deployment of application into pods, application running in pods, issues with application running in the pods, resource utilization. So this can be used as a bare minimum observability tool. Secondly, Prometheus is a collection and storage of observability data. So it provides you with a multi-dimensional data model with time series format, and it also provides a query language called PromQL to analyze. Further, several modes can be are available with different type of graphs as well as dashboards. Prometheus can be integrated with many things like the Grafana and all that as well. So on Grafana side, it will give you a visualizing observability data. So Grafana gives you a data-rich dashboard and using information sources like the Prometheus, like I just mentioned. And it also provides you built-in dashboards for Kubernetes, like actually 4 dashboards. One is the cluster dashboard, node dashboard, pod and container dashboard, as well as the deployment dashboard. Further, Grafana has a few more plugins that, for example, Grafana Loki also can give you a similar observability to your Kubernetes environment. And Jaeger is a distributed system tracing system for Kubernetes. They actually came from Uber's engineering team. It gives you end-to-end tracing solution. So it helps you to monitor, troubleshoot transactions in a complex distributed system and help you to identify the root causes as well as optimize performance and latencies and monitor distributed transactions as well. Further, finally, the Elastic Stack. Elastic Stack includes Elasticsearch, which is the analytical engine, and Logstash and Beats captures and sends the log to Elasticsearch, and Kibana you can use it to get the dashboards. You can also drop Logstash and Beats and combine it with something like a Fluent, then you get a EFK stack, which also will give you a stack for you to implement your observability in Kubernetes. With that, because of the scale of modern infrastructure and the dynamic nature of Kubernetes, observability is a critical component. And the 3 pillars I mentioned, that is the log, metrics, tracing, will not only help you to increase the observability, but also help you to gain insights to your infrastructure, regardless of your technology stack that you use. The tools mentioned here are the de facto standard tools used by the cloud native community, and implementing them will help you to gain observability in your Kubernetes environment. Thank you and have a pleasant day.
Thanks, Janaka. It was a great session. Our next session will be very interesting because it's about complexity of cloud native ecosystem. Mike, who is the senior marketing manager at Portainer, and he's going to talk about this based on his years of experience in Kubernetes, cloud native technologies, distributed and many complex computing systems. Prior to joining to Portainer, Mike was a leading person at Cisco on its Kubernetes initiatives. Hi Mike, the stage is yours.
Good morning, everyone, and welcome to what I'm sure is going to be an action-packed day. I'm Michael Chenitz. I'm the head of technical marketing at Pertainer.io, and I'm going to talk to you a bit today about adopting cloud-native tech and why this is awesome, but also needs to happen with eyes wide open. Hopefully, I can share some insights picked up over the many years working with Kubernetes and cloud-native technologies. My background, I've had a pretty varied career so far, and I think it's one that has really helped me immensely and really helped deal with this latest technology trend. I started as an infrastructure engineer, pivoted to an IT architect, pivoted again to a consultant, and that led me to where I got my first taste of cloud native, eventually leading me to the CTO office at Cisco, and now leading up technical marketing over at Pertainer. So let's talk a little bit about disruption. Oh my goodness. What's up with the global economy? It's unbelievably expensive right now. The cost of everything is so high. Gas prices are out of this world. $7 for a head of lettuce. Come on. Running a business is equally as challenging. Staff are demanding higher pay, lots of sick leave to navigate business travel costs are through the roof. VC funding is super tight. And the number of companies that have unfilled vacancies is just insane. So this is causing terrible service across so many areas of business. Have you traveled lately? Have you seen what traveling's like? Because of this, consumers and even businesses with spare money are spending it extremely wisely and only spending it with companies that have a clear point of differentiation, and for business purchases only with proposals that have a rapid ROI. So that's right, there's an economic squeeze right now. It's impacting not only B2C, but B2B. Most companies I speak to have frozen spend on all non-essential projects, and lots have put hiring freezes in place. With this competition and the money being brutal at present, every single company should be looking at how to serve their customers and asking, can I do it better? Unfortunately, there's simply too many organizations that have no financial ability to invest in new digital initiatives, and ultimately, these will perish. However, this doesn't have to be the case. There are so many new cloud-based services that offer immersive digital experiences. That's even smaller enterprises can subscribe and innovate. There's simply no excuse to be a passenger on an impending train wreck. Don't forget that we can compete in the global market, as there's no such thing as domestic loyalty anymore. Just take a look at Amazon.com and Alibaba.com. Thriving as the new hyper-competitive global economy means embracing change and embracing technology. Every single business owner, and in fact, every single business employee, should be thinking, how can I help my company thrive? And what disruptive services can we deliver, or which one of our legacy services can we improve? If you are not looking at what your competitors, global as well as domestic, are offering, then you are already in trouble. You just don't know it yet. Problem is, there's only so much existing teams can do. And so all this information needs to be done with the constraints. How can you embrace the new now without incurring substantial costs, increments in people, or tooling? This is the art. So let's get down to it. This is where the magic of cloud native comes in. Cloud native is quite simply the very best architecture for digital disruption. Cloud native defines the way that you deploy and manage applications that support digital services. It's more than just the technology, it's an architectural philosophy. Cloud native apps take the very best from what we have learned over the last 10 years around how we should architect, build, support, and scale applications. And cloud native lets you start small, scale on demand, innovate discrete components, and due to that nature, build with extreme efficacy. No need for heavy servers, expensive proprietary software, or anything like that. Cloud native defines the applications are inherently portable, free from vendor lock-in, and provides versions extensible APIs that make it simpler to manage resources and services. It doesn't matter if you're innovating in the data center, in the cloud, on the factory floor. Cloud native apps help you build fast, learn fast, and improve fast. Cloud native apps let you get a product into market in the fastest possible way because you can launch an MVP and then iterate quickly thanks to a microservices-based architecture. You can evolve discrete elements of your service based on user feedback, adoption, and you can do this in a really low-cost manner. Heck, the vast majority of modern CN applications are based off open source components. So you have no expensive DB costs, no expensive application server from top-tier vendors, and no expensive API gateways. All this is made with reusable and free components, so no commitment upfront cost to try out crazy ideas. Of course, you can buy CN apps made by ISVs, and that is still the recommended approach for smaller orgs. But you need to be sure that your ISV is genuinely designing in CN architectures so as to facilitate rapid and non-intrusive updates of their software in your environment. Okay, so now what? To go all in cloud native, you need to consider three things. One, how will you get the apps you need? Will you build them yourself or will you buy them? How will you get yourself a platform to run these apps on? How will you support it, update it, and triage it? How will your users deploy it? And how will you get your application live and keep it live? No point investing in an awesome app if your platform is up and down like a yo-yo. There's a pretty simple way to determine if you should build or buy, and that is there something out there already that does the job? If the answer is yes, then it's almost always better to buy than build. Trust me, even if something is 90% good enough to try and develop your own application that meets 100% of your needs will cost way more and take way longer than you expect. There's really only one good reason for building versus buying. It's when you're disrupting an industry and your technology solution will be your primary point of differentiation. Here's where I might get a bit jumbled, but pretty much any system of record should be procured, as the risks are just too high to build your own. Systems of differentiation and system of innovation, however, are where you get choice. Again, if you're just wanting an e-commerce site, are you sure that Shopify, Magento, or any of the other famous engines are not good enough, customizable enough? Are you sure that you want to reinvent the wheel? It might be better to spend 100 hours customizing an off-the-shelf app than 500 hours building your own. Unless you have a massive in-house development shop or an external contract development house, I would not even begin to recommend creating something from scratch. Heck, look at my own company, Portainer. We have spent over $10 million in 2 years creating a Kubernetes management tooling. Do you think that 3 internal developers could build something as good? Take the lessons and translate it into your app stack. Most devs are either .NET or JavaScript, and experience building either web apps or installable apps. Very few, in fact, we probably have all of you in this very room, develop in microservices and deploying containers. There are so very few cloud native devs that companies elect to self-build new apps. They need to be sure that they can recruit and retain one of you. If you cannot attract and retain cloud native devs, then I would strongly recommend the services or specialist development houses. If you are a cloud native dev, congratulations. Encourage your mates to learn the new stack. Okay, so now you've selected your app stack and you're either going to buy or build. But now what? You need somewhere to run this stack, and that somewhere likely ends up being a container platform. Today, there are 2 primary container platforms, Docker for smaller deployments, and I would argue for development, and Kubernetes for everything else. Unless you have been living under rock, you will be very aware that Kubernetes and its ability to run container-based apps is in a highly automated way across on-prem or cloud, truly unlocking hybrid cloud and removing platform lock-in. Kubernetes is awesome, and it's really simply awesome. It's the cleanest way to run modern IT stacks, and so it's something we all need to get comfortable with. But neither Docker or Kubernetes should be considered a platform. they're an orchestrator, which is just one element of a platform. Kubernetes is no more of a platform than an engine in a car. Then the engine alone won't get you down the road to the shops you need. You need a car for that. Kubernetes is the same. Kubernetes plus some servers on-prem or cloud get you the ability to deploy containers. But it doesn't give you much more than that. It's lacking the native tooling required to get into production and to deliver acceptable SLAs. A platform comprises all of these elements. You cannot fully embrace Kubernetes without the ability to triage container-based apps, view logs from short-lived and highly dynamic workloads, and automate the continuous deployment of applications. Running an app in Kubernetes is useless without people being able to connect to it. So inevitably, you'll also have to load balancer, proxy, DNS server, and dynamic SSL certs to manage. You cannot pass security muster without being able to securely store and scan the container images. And for sure, you should have policies and controls over Kubernetes itself. And you cannot have persistent apps without some degree of persistent storage, which also mandates backup and recovery for that data. So when someone says Kubernetes, assume they mean all the above. It's why I laugh when I hear people saying that they've adopted Kubernetes, have decided on AKS, EKS, and have made no consideration for the additional tooling needed. I'm sure you've all seen the CNCF landscape. It's a mind-boggling number of members. These are all here because they are an ecosystem that surrounds Kubernetes. And there are vendors, providers of the tech that enable the platform mentioned prior. You need to be super careful not to get drowned in here, though. So much choice is good, but it's also very bad. With all that choice, how do you find the good from the average? How can you know which products are worthy of your time to invest pilot? How do you know what can be here 6 to 12 months from now? There are a lot of tools that have been donated to the CNCF because their original creators were overwhelmed at the cost to maintain, and so they have donated to the CNCF. The shift, the burden of maintenance to CNCF is the main reason. This is good if there is a contributor pool, but if there's not, the tools age out quite quickly. Even for those, they retain their open source projects under their own entity. It's not sustainable to support them. They also end up dead. Be sure to be careful when you choose a tool. Make sure it's under active development. Make sure it's backed by a commercial entity. Make sure the commercial entity has a way to sustain their open source product, and make sure that other people are using it. Lastly, things you want to be unique when it comes to the tools, these are very rarely a point of differentiation for you. Are you navigating the CNCF landscape and looking to select tools? Be super aware of compounding complexity. The Kubernetes API is a fast-moving target, and APIs are deprecated and brought from alpha to beta to release at nearly the speed of light. Every product you choose that uses these APIs needs to release a version in lockstep, and the more you have, the greater the chance of finding yourself in a position where you cannot upgrade Kubernetes because of the tool you rely on doesn't support the new version. That's dangerous given the pace at which CVEs are found and fixed in Kubernetes. You should upgrade as soon as possible, but not be forced to wait. Sometimes a multi-tool is the best, as a multi-tool is managed as a single package, so you don't need to do the work to figure out how the interop matrices work. The multi-tool suppliers will do just that for you. As an example, multi-tool, Red Hat OpenShift or Patainer, one vendor, one tool to manage the complexity of a number of underlying technologies. Remember that the more tools you adopt to create your platform, the more tools your people need to learn, the more tools you need to be secure, and the more tools you need to update. Be careful what you wish for. At the end of the day, you are assembling a platform for two reasons. Make it easier. This meme is pretty well known, but the thing is, it's accurate. There's a lot to know about Kubernetes and a lot of things to trip you up. It's critical that the complexity is well understood, respected, and that a plan is in place to be dealt with this. Don't be fooled by those that said Kubernetes is easy. They are ignorant to the true complexity that lays under the surface. Sure, it's easy once you're a trained expert, but none of us are born experts in anything. There are a number of day two challenges that you will need to overcome. Again, these are challenges due to the challenge in architecture, and none of these should be a surprise. When it comes to your Kubernetes clusters, do you want to treat them as cattle or pets? Pets mean you need to update them, triage them, closely manage them, and cattle means you deploy a cluster to host your apps, and then there is a newer version. You spin up the new cluster, deploy your app there, and delete the old. Far simpler. How would you monitor and report on SLAs? How would you ensure security and compliance? How would you back up and provide? If you are modernizing legacy apps, are the ISVs comfortable in supporting them in containers? Kubernetes is designed to be dynamic. If you have a cab board, they can accommodate this dynamic nature. But don't try and be a hero. Sure, it's awesome to be the first company to adopt a new technology from CNCF landscape, but really is it that smart? What happens if you have an issue and there's no peers around you to help you out? Ideally, you want a local ecosystem around you, around the tooling. Local events, local meetups, and locals all talk about the same tech stack. That's a massive risk reducer, so don't fall into that trap. Also, resist the urge to build a better mousetrap. Sure, you're a developer engineer and you like having the skills to build apps and solutions, but is it really a good use of your time to try and build a better tool that's already out there, already being maintained, and already having a support network? Bash scripts, PowerShell scripts, these are all nightmare to maintain versus readily available tools and predictable release cadence. My advice is to ask yourself, can I pass the 3 a.m. test, which is, it's 3 a.m., the system has suffered a catastrophic failure, how many of my teams can rally around to help fix it? If the answer is 1 or 2, you're in trouble. I also strongly recommend ensuring you have a vendor support for open source components too. Sure, they have no upfront license costs, but then again, at 3 a.m., MongoDB has failed. Wouldn't it be great to be able to call customer support somewhere? It's why VMware, Nutanix, MS all did it well, supporting these at times of crisis. And never lose sight of the goal. Remember, slide 1, we're doing all this for one reason only, to help your business thrive. We're not doing this because the tech is cool. It is cool, but it's irrelevant. We're doing this because it's the best way to deliver game-changing digital services to the market. And so don't get tech drunk, remain focused, and apply the value of your time. Once you apply a value to your time, you'll spend far less time thrashing around and make quick decisions based off decisions that others have made before. Then sit back and relish in the fact that you are helping your business thrive. Thank you and enjoy the conference.
Thank you, Mike. We hope you enjoyed Michael's session. So yeah, we believe cloud native ecosystem will help startup to enterprise companies to build their own solutions. Our next session is going to be a pretty interesting one. We know when you are working with Kubernetes workloads, there's a huge deal to improve the efficiency and cost of running it. So Carpenter is an open source by AWS, flexible, high performance, node provisioning tool built for Kubernetes. Rohini is the best person to talk about how Carpenter helps developers to build their workloads. Over the years, she has worked in multiple roles like solution architect, support engineer in different geographies by helping customers. She is passionate to share her experiences and help strengthen the builders of tomorrow. Here's Rohini, who is the senior developer advocate at AWS, and we honor to say AWS is the gold sponsor of KCD itself. Rohini, stage is yours.
Oh, thank you for joining this session. My name is Rohini Gaonkar and I'm a senior developer advocate at AWS. Today, we are talking about Carpenter, an open source Kubernetes cluster autoscaler. If you have more questions, feel free to reach out to me via LinkedIn on the given website. So let's quickly look at different ways we can do Kubernetes scaling. Remember, the goal here is to efficiently use the infrastructure, have less wastage and save cost, and ensure a more highly available application. So there are 3 main concepts, and let's look at each of them. In the horizontal pod autoscaling or HPA, you scale or add more number of pods based on the resource metrics. So it is pod level scaling. You simply start adding more and more number of pods as your demand increases. And if your demand decreases, you simply automatically stop the pods to free the resources. So you scale out and scale in as per your need. With vertical scaling, as it suggests, adding capacity to the same resource. So the Kubernetes VPA automatically adjusts the CPU and memory reservation for your pods to help right-size your applications. And finally, the Kubernetes Cluster Autoscaler, which is a popular cluster autoscaling solution maintained by SIG Autoscaling. It automatically adjusts the number of nodes in your cluster, so when your pods fail or are rescheduled onto other nodes. It is responsible for ensuring that your cluster has enough nodes to schedule your pods without wasting resources. So it watches for pods that have failed to schedule and for nodes that are underutilized. And it then simulates the addition or removal of nodes before applying the change to your cluster. Now, the AWS Cloud Provider implementation within the Cluster Autoscaler controls the desired replicas field of the EC2 autoscaling group. You need to make sure that each type has roughly the same amount of CPU and memory resources. Otherwise, resources might be wasted or insufficient during a scale-up. To support different instance types, you need multiple node groups. Also, as I mentioned, it's recommended that each node group span only one availability zone. So to make sure that if you want your workload to span across multiple availability zones for high availability, you need a node group per instance type per availability zone. Well, Cluster Autoscaler was not originally built with the flexibility to handle hundreds of instance types across multiple availability zones. It loads the entire cluster state into memory, the nodes, then pods, and the node groups, identifies the unscheduled pods in the cluster, and simulates the scheduling for each node group. So when you have lots of node groups, this gets very complicated. And when run at scale, it often takes up to 5 minutes to actually scale your capacity in your cluster. This can have significant impact in use cases where the speed of capacity scaling is very critical. It could also have a real customer impact as customers are not able to meet the commitments of their end users. So it's hard to get the high cluster utilization and efficiency of operations. Customers of AWS have over-provisioned resources to ensure that a consistent end user experience. I've seen our customers over-provision their infrastructure by 20 to 25% in some cases. And then there are some use cases like machine learning or batch workloads where I need to quickly experiment something. So instead of having to get a node group configured, then get other resources, which actually slows down the pace of innovation. And that's where we need Carpenter. Carpenter is an open source, flexible, high-performance Kubernetes cluster autoscaler that helps improve your application's availability and cluster efficiency. It launches the right-sized compute resources, for example, in our case, Amazon EC2 instances, in response to changing application load in under a minute. Through integrating Kubernetes with AWS, Carpenter can provision just-in-time compute resources that precisely meet the requirements of your workload. What's that asterisk? Well, AWS is the first cloud provider supported by Carpenter, although it is designed to be vendor neutral. Carpenter works in tandem with Kubernetes scheduler by observing the incoming pods over the lifetime of your cluster. So it will launch or terminate your nodes to maximize your application availability and cluster utilization. When there is enough capacity in the cluster, the Kubernetes scheduler will place the incoming pods as usual. When pods are launched and they cannot be scheduled using the existing capacity of your cluster, Carpenter will actually bypass the Kubernetes scheduler and work directly with your provider's compute service. For example, Amazon EC2 instead of autoscaling groups in Cluster Autoscaler. So to launch the minimal compute resources that are needed to fit those pending pods and binds those pods to the nodes that it provisioned. So as the pods are removed or rescheduled to other nodes, Carpenter looks for opportunities to terminate the underutilized nodes as well. Running fewer, larger nodes in your cluster reduces the overhead for daemon sets and Kubernetes system components and provides more opportunities for efficient bin packing. The central concept in Carpenter is provisioner. So we do this using the Kubernetes custom resources. This is a kind of modern way or standard way to write controllers. So a provisioner is how you define how Carpenter will manage the unschedulable pods and the expired nodes. The provisioner comes with some smart defaults, but these are fully configurable, and these defaults include the configuration of the instance type, selection, the launch template generation, the subnet, security groups, etc. etc. So you could think of two personas. Okay, there's an administrator and there's an application developer. It is expected that a cluster administrator would install and update Carpenter, define the provisioners to segment the infrastructure space as needed. So they can define the provisioners based on purchase options, the capacity type, the instance type, the availability zones, etc. And the application developer, who is actually deploying these pods, which might be evaluated by Carpenter. They write the pod manifest. So as long as the requests are not outside of the provisioner's constraints, Carpenter will look for the best match the request, comparing the same well-known labels of Kubernetes defined by the pod scheduling constraints. Note, if the constraints are such that a match is not possible, the pod will remain unscheduled. Kubernetes features that Carpenter supports for scheduling pods include the node affinity, the node selector. It also supports pod disruption budgets, topology spread constraints, inter-pod affinity, and anti-affinity as well. So let's quickly look at our demo. In this demo, I have already set up a Kubernetes cluster. It also has Carpenter installed. You can find all the steps in the Carpenter documentation. I'll provide the link towards the end of this presentation. Okay, I've already set that up. I've also defined a default provisioner. So this is something your administrator could do. So they have defined a default provisioner, and in there I've mentioned that any capacity that you launch should be a spot, should be of this instance type family, and it could be of a certain instance size. Right now it's I have just commented it out, but you can have it of a certain instance size. And I've also mentioned that it should be it should be AMD based instances as well. You can also mention what is the limit of number of CPUs that we would want. How can Carpenter understand where to launch these EC2 instances? Well, I've also mentioned where the subnets are and the security groups are. I've already tagged them, so it will go ahead and discover that, hey, these are the subnets that you want to go ahead and launch your EC2 instances or the nodes that you would need. And there's an important point here that I've mentioned the TTL seconds after MTS 10. What does this mean is that once a node is empty, there are no pods running on it, it will wait for 10 seconds. Carpenter will wait for 10 seconds before terminating that node or that EC2 instance. I've kept it low because it's a demo. I want to show it quickly, but you can keep it higher if you are running a production workload. So I've already applied the default provisioner. All good. What I'm going to do next is going to see that will create more replicas in this case. So before we do that, you can see that there are no pods running right now. You can see that there is only one node running right now, and these are the Carpenter logs. So generally I start with one and escalate it further, but now to save time, what I'm going to do is I am going to just ask for maybe four pods that I wanted to create. The moment I say yes, what it is going to do is it is going to have 4 pods that are in pending state, and you can see in the logs, let's go up a little bit, it says that, hey, create a node with 4 pods requesting certain capacity. Okay, that yes, it is now waiting for this EC2 instance. So it has already created that EC2 instance, and you can find that it has already launched an EC2 instance 23 seconds ago. What is this EC2 instance size? The size is obviously anything that would fit all these 4 pods on, but it is of C5, it is AMD 64, and if you move a little bit here, you could see that it is already spot. And the instance is already running, so it's 39 seconds, but you can see the status has changed from pending to container creating. So as we talked about this in the presentation, when Kubernetes is creating those EC2 instances, it's not only considering that, hey, I need to schedule these, it's not only creating that EC2 instances, but also taking a scheduling decision. So when it is creating these EC2 instances, it is bypassing the kube scheduler, and it's by directly binding these pods to these nodes as well. So you can see within few seconds, like I think it was 58 or 60 seconds, you can see that all these pods are actually running on these EC2 instances. Let's escalate it a little bit. Let's make it, instead of 4, let's say I want 100 pods, and we'll see how quickly Carpenter is able to compute that how many nodes it needs for all these 100 pods, and is going to quickly launch all these EC2 instances. You can see that within seconds that the EC2 instances that it has calculated. So let's go up and see. Okay, so create a node with 85 pods. So it could fit few pods on the other EC2 instance. So it has gone ahead and deployed that. That is something that kube scheduler will do quickly. So if you want, we can also check right away of how many pods are actually in the running state right now. So right now 15 are actually running on the EC2 instance that was ready, or the node that was already ready. The one that is not ready, that's where the other 85 pods are going to be placed. Okay, and you can see that it's already 75 seconds, and the EC2 instance will get ready in few more seconds or couple of minutes more before it can actually have all these pods going and placed on a running state. So by bypassing auto-scaling groups and directly talking to EC2 instances, we are able to save 30 to 35 seconds actually when you're trying to schedule a lot of pods. And if you've seen this, that in 108 seconds, our EC2 instance was up and running. Let's see how many pods are up and running right now. You can see that yes, 20 pods are up and running. There are some in container creating mode, so they are downloading that image and getting ready. And if you want, you can also keep checking that how many of these are getting created. So you can now see that that number has quickly started escalating, and you can, within it's been 2 minutes since that EC2 instance has been launched, and you can see already most of the pods have been deployed. So that's how quickly Carpenter can actually get the EC2 instances up and running. Great. So all the 100 pods are up and running. So what we'll do next is actually just go ahead and remove all these pods. Okay, so I'm just going to say, hey, just go ahead and have 0, and you can see how quickly it is going to scale down. So the pods will go off instantly, but for the EC2 instances, you can see that it has added TTL. If you see the logs that I've highlighted, it says that added TTL to the empty node, and because it was just 10 seconds, it's saying that it's triggered the terminations, and within 10 seconds all my EC2 instances have been deleted. If I want to make it more interesting, I can also go ahead and, let's say, patch the deployment and say, hey, instead of AMD, I want ARM based EC2 instances. And once that is done, I'm going to ask for, let's say, 2 pods that need a node that is ARM based. Now in this case, let's scroll down. We also got ARM based EC2 instances, but they will be like, when didn't you mention AMD already? But yes, I have also applied another. So you'll be able to see that here. 1 second. Okay. So you can see that it already found a provisioner for ARM64, and the request that I just had matched that ARM64 requirement. It was there in one of the provisioners, and so it went ahead and deployed that EC2 instance with ARM64. So you can have multiple provisioners in this case. These provisioners could have different constraints, different requirements, and Carpenter will automatically pick up that, hey, there is already a provisioner. If there was no provisioner for ARM64, it wouldn't have allowed the user to actually go ahead and deploy this particular application. So that's it. That's the simple demo. Let's go back to our presentation and wrap up this section. The key takeaways. So you use the default provisioner for diverse instance types and availability zones. You can add up additional provisioners as you need. You can also control your scheduling based on your topology spreads, your taints and tolerations and provisioners, etc. Use HPA with Carpenter to scale in and out. And you can schedule these pods with Spot if you need to save cost, right? If you want to install Carpenter, you want to play with it, you want to contribute to Carpenter, do check out the documentation and the GitHub link I've mentioned here. There are some best practices that we discussed about how to use this with EKS. There are also certain workshops if you want to do more hands-on with respect to Carpenter, and you can find all that detail on these resources. So that's it. That's me. Thank you for joining me for this quick demo and discussion about Carpenter. I hope this was insightful and this was useful, and I hope we all experiment and continue innovating in the way our Kubernetes clusters are scaling today. So thank you again. See you again next time.
Thank you, Rohini. Yeah, that was a great tool when you're working with kube clusters. We hope you got the best practices to follow while using it. Our next session is going to be kind of exciting one. We have planned to have a panel discussion with Kanchana, yeah, all of you know now, who is the main organizer, VP and GM at WSO2, Eric, who is the CTO at WSO2, and we have Murali from Data Pelak. And also, here with me Chamod and Kavisha to continue the discussion with our panel. I think, first of all, let's get to know how we started our container plus Kubernetes journey. From my end, I also joined a company called Platformer for my internship in 2018, where Kanchana was the co-founder. And as you remember, on that day, I got an opportunity to join the first ever Kubernetes Sri Lanka meetup organized by Platformer together with Kubernetes Sri Lanka community. Honestly, I don't have idea about those sessions that had it on that day, but I was trying to understand by Googling and some other ways what's this Kubernetes and why we need to use it. So while I'm working, one of my colleagues shared a Docker fundamental Udemy course. I was super excited to learn about it. Then I was working with the platform team by building container products. And I'm currently working at Eternum on different Kubernetes projects. How about you, John?
Mine is a bit similar to Camilla's, and I started learning about Kubernetes from Kubernetes Sri Lanka meetup group. But about containers, I learned by trying out Google Quick Labs and Docker Playground. Anything to add, Kavisha?
Yeah, Chamod. When I was hearing about your stories, actually I was an undergraduate, I got to know about the topic Kubernetes. But I already know about the containers and Docker. When I was working in a group project, at that time, I was trying to troubleshoot in an app which was working on my laptop, but not working in my friend's laptop due to a dependency issue. It made me to Googling a solution, and I was able to solve the issue by containerizing the application. Yeah, that was pretty much about me. How about you, Kanchana?
So my journey actually goes really long way back, but it didn't actually kind of end there. This was the days of when Sun Solaris had zones, so BSD, jails, what have you. But it was very challenging to use. It didn't call containerization. It was kind of like separating what you're running within a physical machine. And practically kind of everyone gave up. But then when Docker started in 2013, I got really hooked into it. And then over time, as Docker matures, I was building our own company, Platformer, and then we were kind of very close to building what Borg was, Kubernetes was going to build. But when we heard about Google kind of working this, we decided we actually kind of put our efforts into work with them and actually build our platform around Kubernetes, right? So yeah, so I think it was kind of 20 plus years ago, start and stop, because it was very hard to use containers back then, which wasn't really called containers, but yeah, most recently with the advancement of Docker and so on and so forth, that was kind of my journeys. But over the last 7-8 years, I have seen significant improvement in this, and will continue to evolve.
Well, I trace it back to a presentation again at HPTS in 2007 from Google, where they explained the decisions to create their commodity data center architecture. And I realized from that they had reinvented IT, and we needed to think about moving all of our systems over because they had created the most cost-effective, scalable infrastructure. There were implications for all software, and this is why we have cloud-native software, why we have Kafka instead of MQ, and why we have NoSQL instead of SQL, because not only applications had to be reinvented, but the system software as well, because the different way in which the infrastructure worked and the software on top of it to isolate the applications from the constant failure of consumer-grade hardware. Adrian Cockcroft was at the same presentation. I've known him for many years as well. When he was at Sun, I was at Digital. And I followed his journey to Netflix very closely. And from that, when I got to Citi, decided to follow Netflix. Adrian came to talk with us several times, and he was the one who told us about Docker. And he said, this has solved the problem of containerization. The next big challenge is container orchestration, which turned out to be Kubernetes. And during that time, I was working primarily on service-oriented architecture designs and implementations, first at Credit Suisse, where I went after I was at Iona. They were a big customer of Iona's to help there. And then at Citi, CIO one time, to catch up, and he asked what I was working on. I told him about SOA and managed evolution, modernizing IT systems, and he said, I don't want you to do that. You might break something. No, we're not going to break anything. Said, but you might, so I'm not sure you should do that. So I said, well, what about this stuff Google is doing? Are you interested in that? He said, oh yes, that sounds really interesting. So he allowed me to sponsor a project to redesign our payment processing systems using microservices in the cloud. So we spent several months doing this, and instead of batch-based, we had event-based microservices. Then we set out to find the implementation. We had first evaluated Cloud Foundry, couldn't get it to work. Then we got OpenShift, and that worked, and then we started our journey on that. And coming to WSO2, I found when I spoke with Sanjeeva, so just about 2 years ago now, what he was working on for Ballerina and Choreo in the area of cloud native solves a huge problem that we found at Citi, which was even if we understood the benefits of getting payment processing systems to the cloud to have the scale up, the auto scale and scale down for seasonal workloads, we had a huge challenge understanding how to do it, getting people who understood the difference between microservice and monoliths and how to recode them. And the stuff that we're working on WSO2 really should help with that in a great way. So this is kind of where I am on that journey, and I hope it's going to have a good ending.
Thank you, Eric. Murli, you want to?
Yeah, so Kanchan and Eric shared a lot of historical points, so I will cut down on the history part, but I would say I formally joined the bandwagon in probably like mid-2015, when I started looking at Docker, and then I joined the startup. We were trying to build a container as service platform, and that kind of didn't pan out, and I was looking around, and at the time there were not many options, right? Like Docker itself, and then Apsera and Rancher, and finally I decided Rancher is a great place to work on container stuff, and it has been an amazing journey for almost like 5.5 years. And even now in the current startup that I'm working at, we are still using containers for various things. So it's still an ongoing journey.
Yes.
It is an ongoing journey. That's right. Absolutely.
Thank you very much.
Thank you, both of you. Back to the panel. Yeah, back to the
thank you very much,
host.
Kanchan. All right, let's move on to the questions that we have planned to ask from our panelists. So, as the first one, why do you think Kubernetes still used by different cloud providers as managed service? Anything to add, Kanchan, from your end?
No, I'm probably going to ask Eric and Murali. I think the managed Kubernetes space is growing compared to customers, deploying their own Kubernetes onto public cloud. So maybe Murali or Eric can answer first, and then we can go for a bit of a discussion.
Well, sure. I can say what we did at City while I was there. I left about a year and a half ago, and before that I was leading cloud migration for one of the divisions. We had chosen OpenShift as Kubernetes on the idea that this could be used anywhere. We had a private cloud internally built for us by Dell, and we deployed initially internally, and then we were moving to AWS. We did a pilot for that. I did that myself, and we found it was very difficult to fit OpenShift into all of the AWS cloud native services. So I think the value prop for the cloud providers to have a managed hosted Kubernetes is that they can integrate it with all their monitoring tools and security and reporting and analytics that are difficult to handle, as we found out when you're bringing a separate Kubernetes product into the cloud. They, at the time, were not as mature, and in the consumer part of the bank, they were trying to use EKS from Amazon and found a lot of security challenges. But I believe they have been working on those the last year and a half or so and have solved most of them. But I think it's anything else for them. Part of the value proposition of moving applications to the cloud, Kubernetes is the default deployment, and providing it as a service and integrating with all their other services is how they try to attract and keep customers and compete with one another.
So, thank you, Eric. Murali, anything you might want to add in terms of your experience of managed versus, bring your own?
Actually, you're on mute.
Eric's question is, Eric's answer is pretty valid. You get to use the native services of the cloud provider if you use the managed service, right? So just to add on top of it, the next thing that I can think of is support, right? If let's say you are building your own Kubernetes stack on top of let's say AWS, then who is responsible for the support, right? So that's probably one of the reasons why people are trying to adopt the managed services. And to add kind of a another paradigm is, the ramp-up time is pretty fast if you are trying to use managed services. You don't have to deal with automation, you don't have to train your team to, or expose them to tools like, K3S or, some other tools like OpenShift or Rancher, right? So you can just start and then start running your applications. So probably these are some of the reasons. And the other reason that I can think of is, if you are a customer who is trying to run Kubernetes on-prem, then pretty much you don't have much options there, right? So you would end up going with, building your own Kubernetes stack. So in that case, even if you expand your footprint to the cloud, you would end up building your own Kubernetes stack, because it's kind of natural. You build the stack for on-prem, so you're just extending it to the cloud. So these are some of the reasons I can think of why people would work with managed services versus build their own stack.
Thank you, Murali. I think that's probably why especially Google gone another step ahead, isn't it? Like the Google GKE Autopilot, they call it, which is completely managed and kind of serverless Kubernetes in GCP, where you don't have to even figure out how many nodes and things like that you want, and they'll actually do that for you. Thank you very much, both of you. Kamila, are we moving on to the next question, or do you want me to ask the next question?
Chamod will ask the next question.
Okay.
Right.
So the second question is, why do you think rather than Docker Swarm, Kubernetes got popular with a huge hype? Any specific reasons?
Should I take that now?
Go ahead, Eric.
Go for it.
Go ahead.
Yeah, I look at this, try to look at this a bit from first principles. And I remember I was attending a conference in 2015, HPTS in California. We had a speaker from Google, his name was John Wilkes, and he gave us a talk about Borg, and he gave us a demo of Borg. And this is where Kubernetes comes from. It was developed initially as Borg by Google and open sourced into Kubernetes together with Red Hat and some other companies, I think, as we know the story. And his demo was to show how he could deploy 10,000 copies of a simple Hello World program in a matter of seconds using Borg. And I think what's very important about Kubernetes is that it's solving a very important problem in cloud computing, which is, as he mentioned, he was showing these arrays of commodity servers, which I think you can see if you check for Google data centers or Azure data centers or Amazon data centers, you see racks and racks of consumer grade hardware. This is a huge difference from how we used to do systems on enterprise grade mainframes and servers made for specific loads and specific programs running on specific nodes. And in this environment where you're running on consumer grade hardware, you're running at very low cost, the lowest cost possible, but you have a highest failure rate compared to enterprise software. So what you need to do is to have a way to deliver multiple copies of programs so that if you have a failure, another copy is able to take its place. And in his presentation, he mentioned that for every 2,000 machine service deployments that you have in those large racks, it's very common to have more than 10 exits per day. And they expect this. And Kubernetes is really coming from this world of, I have consumer grade hardware, I have racks and racks of servers, I have the lowest cost approach to IT possible. But in order to make the low cost work, I have to be able to sustain the failure rates of consumer grade hardware and everything keeps going. And Kubernetes comes out of that and became the default way to deploy your container-based microservices to achieve all these benefits of cloud computing. And I think that's the key problem that it solves, and that's why it's becoming very popular.
Thank you, Eric. Murli, do you want to add anything, or do you want me to have a go?
Yeah. Eric covered like a very good point. Just the way a person, if you have to compare Kubernetes with a person, right? The technical aspects are the hard skills, right? And the soft skills are the community. We have a very vibrant community around the entire Kubernetes ecosystem. So that kind of helped, build the momentum and take it forward. That's the other point that I would like to add.
100% agree. Yeah, I think that was one of the biggest things that the Kubernetes and Google and Red Hat and IBM, the early contributors, were able to do compared to Docker. I think Docker kept it to their heart, very close to right. They didn't get a lot of community involvement, so on and so forth. I think I kind of at one point saw like they were kind of almost going to create that as a proprietary thing for themselves, rather than engage with the community. We saw the same thing happen with Mesos. Mesos was open source, but they also did not entertain a lot of community, right? I think that was one of the other key things the Kubernetes got so popular, that the engagement with the communities was really big. And while those three were the biggest contributors back then, I think there are a lot of others to actually contribute. Now they have kind of become, they are still significant contributors, but they are more like, less of a contributors rather than the majority of the other contributors.
Thank you very much, Kanjan.
Yeah.
That was awesome.
So, next question from me. So, what's your perspective of using an open source monitoring and logging tool rather than going with a subscription one for a production environment? I know some of the companies highly recommend to use StackDrive, ELK Stack, and New Relic, likewise some payable monitoring mechanism. Yeah. I think hope it's clear, Kanchana.
What's your
Yes,
thought?
yes, the question is clear.
Yeah.
Question is clear. Eric, Murali, do you want me to kind of repeat the
Yeah.
question, or you guys got the question?
I'm okay. Morelli,
Yeah,
you
I'm
want to
okay.
start this one?
Yeah, I'm okay. Yeah.
You want to start this one, Morelli? I started the last
Yeah,
two.
sure. I can take this one. So, if I understand correctly, why would somebody build their own monitoring stack versus use some subscription model, right? Just to make sure, right? So my take is it's all dependent on business needs, right? So most of the times, let's say if you're a startup, you don't have much time to build out the tech team around monitoring, build that focus, build that automation, scale out everything, right? So what you would do is you consume the readily available stacks, and once you grow beyond a certain critical mass, then you would probably evaluate, okay, does it make sense? The cost to value ratio, does it still make sense? Does the subscription make sense, or would it make sense if we build out our own stack? Would there be cost benefits? Would we have better control on the infrastructure and things like that, right? So these discussions are kind of a natural progression as the teams evolve from small size to bigger size. So it's more on the business requirements. I think there's no hard and fast rule. Depending on a particular business needs or a team's needs.
Absolutely, completely agree. One thing I could add is there's an inertia factor sometimes. For example, at Citi, they were using Splunk very extensively, and the natural thought was, let's just keep using it, even when we're going to the cloud. Sometimes it's difficult to rethink the problem in the context that you just explained, Morali, which is the sensible way to do it. If you've made a decision years ago that you just want to stick with for some reason, or some people do, so that may create a challenge for some to do so. But I think it is some important question to rethink, especially moving to the cloud.
Absolutely. Yeah, add to that, Eric. Yeah, I think previously like NBN, similarly, they also continue to use Splunk, even though it became quite expensive. It is also at the same time quite challenging to move on to either an open source or another product, right? That's also in their minds. I think the subscription-based monitoring and observability teams products have become really smart in terms of the way they charge, right? And we know even Azure Analytics or Slack Driver, they charge for the gigabytes of data that you actually push, and that can grow really, really rapidly over time with microservices, right? So. Yeah, I think closing on that one, I think like Murali and Eric said, it's pretty hard to say that whether you should go on one or the other. But if it's a startup, I think it's kind of highly recommended. You start with some of the readily available SaaS tools rather than actually going to try and establish your own stack, because you can actually spend quite a lot of effort and time and money also actually getting resources to do that.
Thanks,
Thank you guys.
Thank you.
So, next question is, do you think over time the dominance of VMware will fade away with companies such as Google AWS is starting to offer Kubernetes to run bare metal in their private data center? Or do you think most of the customers will move to manage Kubernetes services in public cloud providers and decommission VMware infrastructures?
I think it's kind of into two questions, isn't it? So
yeah,
maybe we should break it up. Yeah. I think the first part of the questions, I think Shamoth was trying to ask whether the dominance of VMware will fade away because Google and AWS and others are coming into your own data center with their own Anthos and Google Outpost and Azure HCI stacks, or whether they will actually completely forget about all that. That's the second question, and just use public cloud.
Yeah.
Maybe Murali, you want to go with this
sure.
one?
Yeah, sure. So my thought process is like, VMware still has a stronghold in majority of the enterprises, right? So the main reason is it works pretty flawlessly for most of the business use cases. And the reason why people still use their own infrastructure is because of the data security. There will be compliance reasons, there will be some other reasons where a particular company doesn't want to push out the sensitive data out into the cloud, right? So in that case, VMware makes sense. So as long as that particular need is present, VMware or any of the other bare metal providers like Nutanix, they're not going away. And again, like building Kubernetes stacks versus managed services, again, like we just had that discussion, right? Like it depends. Yeah, it again depends. Yeah.
Anything to add, Eric?
I think VMware is on the way out, basically. It's going to take a very, very long time. As Murali said, it's very well established, and a lot of people are still using it and still finding value in it. But the original reason it was created to virtualize the operating system in a large data center and to create virtual machines independently for applications and developers to segment resources of the operating system. This reason is really not very compelling in the industry anymore for something like VMware to exist. When you look at the cloud architectures of hundreds and thousands of machines, they're more interested in the operating system level and the Kubernetes level, the deployment level, the container level of things than they are in the virtualization. And in those environments, virtualization can add an overhead which may not be helpful. So I think the original reason VMware was created was for the scale-up environment, to segment, to break it up into smaller pieces. And now in the cloud, everything is broken up into smaller pieces already. And so I think over time, the innovation is going to come more at the operating system level than at the virtual machine level for that environment going forward.
Yeah, I think you both covered it really, really well. And I also think, like both of you said, VMware got a very strong foothold, so it's going to take a while to, fed their, install base, I would say. We yet to see what Broadcom will do, but I don't think customers will jump the ship just because it got acquired by Broadcom, right? Yeah.
I don't think so, but I also wonder whether Broadcom can sustain innovation and a future vision for that, for VMware.
That's right. That's a very valid point too. Yeah. Thank you, Eric and Murali, on that one. Back to you guys.
Yes, Chamod. Yes, Kanchana. Sorry. So next question is about managing complex application. So when managing complex distribution application on KX is still a challenge, So many companies are coming with application packaging frameworks, to name few: Open Application Model, Dapper, and most recently Archon Labs. So what's your thoughts on that actually so far?
It's a difficult question because the reason, as we talked earlier about, the reason Kubernetes was developed was to deploy small pieces of code onto small computers, hundreds and hundreds of small computers automatically. And yet Kubernetes has no inherent restriction on running large applications and large programs. It's very possible to take a monolithic Java EE server and run it in a Kubernetes pod, given its sufficient resources. It's not the best way to use Kubernetes because it's not consistent with what the problem with Kubernetes was designed to solve. But it can be a transitional step. So I think the companies who are thinking of this, and we this is one of the reasons at Citi when I actually introduced OpenShift into Citi and ran the initial proof of concepts and did the first applications on it. And one of the reasons we chose it in my division over Cloud Foundry, for example, was Cloud Foundry was much too strict on the 12 factors, and they also didn't have capability to run the data tier very well at that time, which was 2015, I think. Anyway, it served us better because we had a way to make the transition in steps to the microservices world that we wanted to get to. But microservices being such a different way to compose and run and manage applications, it requires some investment and some re-engineering, and it's not possible to do that all at once. So OpenShift and Kubernetes version of OpenShift's version of Kubernetes allowed that transition to be taking place gradually. So I think that there's some often confusion between the fact you can run something on Kubernetes and what you should really be running on Kubernetes. Just because it works doesn't mean it's the right thing to run there. And it may take some time for that to become apparent and for that scenario to play out, especially as companies move through that transition from monolith to microservices.
Thank you, Eric. Murli, you want to add anything to that?
Yeah. Just a slightly different perspective, but it's very similar to what Eric just mentioned, right? So Kubernetes was never designed with the intention that it would be consumed by the end users, right? So you always need some kind of an abstraction or some kind of management layer on top of it, which would make it easy to work with the entire Kubernetes stack. And platforms like OpenShift, Rancher attempted to do that, and they got a lot of adoption. And obviously the next progression is how do you simplify app deployment? How do you compose the entire app specification? People fell in love with the Docker user experience, right? It was so simple. If you look at Kubernetes manifest files, nobody can author one from scratch. If you look at a simple Docker compose file, you could probably just hand write it, or hand code it, right? You can't do that with any of the Kubernetes manifest file. You need to copy paste, or you need to use some kind of a generator. Although there are other wrappers on top of it, but still, it's not easy. So
quite complex, isn't it?
It's quite complex. So I think it's kind of a natural progression, but at least now what has happened is Kubernetes has become the de facto standard, just like Linux kernel, right? It's adopted, huge adoption, and very similar to what how the Linux environment evolved, right? I remember back in my college days, I used to have 3 CDs of this Linux distribution, and getting it to install on my desktop was a pain. It was very difficult. The drivers wouldn't work, the network card doesn't come out, hacking a lot of stuff, right? But now if you look at it, you just have a USB stick, you plug it in, boom, you have everything installed, right? So in the same way, Kubernetes, the whole ecosystem would evolve where it would be just plug and play. So that's why all these companies are trying to solve that user experience problem.
Exactly. I think the one which is very, very new, I think the newest the newest kid on the block is your former co-founders, the Rancher co-founders has gone and created this thing called Archon Labs, and I'm really interested to hear what they have to say. I think if I'm not mistaken, I think Darren is planning to do a technical demo in this KCD. So hopefully we'll get to hear from him as well. Yeah. So
yes, I happened to I think the first meetup actually last. I think probably Wednesday or Thursday we had the first online meetup, and I.
That's right. Yeah, I missed it because it was kind of too late in the day for me. But interesting to hear what they have to say. They come up with a completely different way of kind of packaging the applications, right?
Yeah.
To a certain extent, I think some of the other tools are also trying to do similar, a way of simplifying it. But yeah, that's right. I think it's evolving, right? It's not going to. Kubernetes. I think Eric. I think when we talk about it like it's the new Linux of the cloud, right?
Well, I think Murali said it's the new standard for deployment. And
that's right.
You get a standard like this. And I think I was also a good comparison of the evolution of Linux. At one time was not a standard operating system. And over time, once you establish a standard, you can start working above it and start to abstract it. And that's what we're seeing, I think, in the marketplace as well. Kanchan and Murali's a number of companies now coming out, ourselves included, with the capability of abstracting across Kubernetes for applications that are deployed on them. And I think that's very much next logical step as well, including not just the tools, but also abstracting many common application capabilities.
Right. I think we are right at the top of the hour. Is there any other questions or things that?
Thank you very much, Kanchana, Murali, and Eric. Yeah, that was a great session. We honor to be here. Back to you, Chirag.
Thank you, folks. It was a great discussion, and there was a lot to learn through your experiences and knowledge. Now, let's move on to our final session for the first day. This is powered by our silver sponsor of KCDSL 2022, Senath Limited. Here, we are going to talk about Ballerina. Ballerina is an open source cloud native programming language that focused on integration in the journey from code to cloud. It helps to simplify the cloud native application development by simplifying the network services. We have Dakshita here to show us how we can leverage Ballerina for cloud native application development. She is currently working as WSO2 as a developer advocate, and she has over 10 years of experience in the roles of software engineer, solution architect, technology evangelist, program manager, and developer advocate at WSO2. Hi Dakshita, the stage is yours.
Hi everyone, I'm delighted to be speaking at Kubernetes Days Sri Lanka 2022. My name is Dakshita Ratnayaka and I am a developer advocate at WSO2. And I'll be talking about how you can simplify network services for real-world cloud-native applications with the Ballerina programming language. So, what are network services? They're pretty much APIs or microservices, which are core components of cloud-native computing. Breaking applications into small, loosely coupled parts makes it easier for developers to build agile and resilient software. So these network services can be in the form of a REST API, a GraphQL API, or a gRPC service, and so on. So what is it like to build network services? Distributed applications are complex. So when you're dealing with a network, errors are a normal part of doing business, especially when you consider the 8 fallacies of distributed computing that you can see on this slide. To build cloud-native applications with network services, developers must be well-versed in the right tools, programming languages, and development and deployment techniques. So, in light of this, what's the role of the programming language that you use to develop network services? Can you use any mainstream popular programming language to build your service and APIs? Yes, most of the time. Some are more suited than others, but are these languages truly cloud native? Or are they repurposed for the cloud with libraries and frameworks? What if developers want to go beyond the scope of the framework? Do developers stick to these libraries and frameworks nevertheless because they're familiar with the underlying programming language? And some other questions to ask are, do these languages treat the network aspects as an inherent part of the language? And what about data handling? How do they serialize data on the wire to data in memory? So I can safely say that none of the mainstream programming languages as of now have been purposely built with the right level of abstractions to ease the use and creation of network services. enter the Ballerina programming language. So the key goal of the Ballerina language is to significantly simplify the creation, integration, and usage of APIs or microservices, be it REST, GraphQL, or gRPC. The latest Swan Lake release comes with many remarkable features that will be appreciated by any service developer. So instead of repurposing existing technologies, Ballerina is purposely designed to build interactions over the network, abstracting away the hard parts and allowing you to focus on core business logic. So I'm going to talk about a few characteristics or offerings of the Ballerina language that makes it a really good programming language to program your services. So the first one I want to talk about is the Ballerina language being network oriented. So along with a network aware type system, Ballerina comes with fundamental syntax abstraction for working with network services. So Ballerina has this concept, or it accommodates the concept of a service, and a service can be written in just 3 or 4 lines of Ballerina code. And services in Ballerina are powered by listeners and libraries, and so that's how a service can work, right? And because Ballerina's service approach is coupled with its unique wire-oriented type system, you can generate an interface description from the Ballerina code. So this can be an open API spec, an async API specification, or a GraphQL specification. So you can actually write regular Ballerina service objects and generate your client code. So the combination of these features enables cloud integration to work smoothly. And then you also have client objects. So like you have service objects, you also have client objects to consume remote services. The outbound network interactions are represented by client objects, and clients have remote methods that represent outbound interactions with a remote system. And you also have sequence diagrams for network interactions. So I'll be showing that in one of the later slides. And Ballerina is data-oriented and is not object-oriented. In network interactions, the object-oriented approach bundles data with the code, which is not the most optimal way to send data across widely distributed networks of microservices and APIs. And that's why Ballerina comes with a network-friendly type system with powerful features to handle data on the wire. Ballerina's plain in-memory data values are pretty much in-memory JSON. So this allows a JSON payload from the wire to come immediately into the language and be operated on without transformation or serialization. We know that JSON is the most widely used format in the network today. So Ballerina also comes with a set of language features for working on data, out of which the integrated query feature stands out. So this feature basically allows you to query the data using an SQL-like syntax or query. So basically, query expressions contain a set of clauses similar to SQL to process the data. And there's also a table data which makes it easy to work with relational and tabular data. So Ballerina allows you to do enterprise-grade development. So that means basically to run services reliably, securely, and safely for a long period of time on multiple environments. Ballerina provides these capabilities. So when you're talking about configurability, Ballerina takes the concept of configurability into the language. and that allows us to keep the same program and move from one environment to another environment without being explicit about what the dependencies are. And then you have transactions. Writing ballerina programs that use transactions is quite straightforward because transactions are a language feature. Transactions in ballerina also work well with the network interaction features. That means the clients and services to support distributed transactions. A lot of effort has been taken to handle errors reliably and consistently within the ballerina language. You have to be able to look at the program and understand if there is an error, where an error could take place, and how the flow of control is going to change. So without using exceptions, ballerina allows the developer to use the error data type with explicit error control flow. When we talk about concurrency is a fundamental requirement in the cloud because your network operations have high latency. So using threads and strands for asynchronous communication, ballerina provides a simpler and intuitive approach to concurrency. Then it's important to highlight that while ballerina provides better ways to write services, it also comes with a subset of features that are familiar to a programmer of a C family language, such as Java, C++, or C. And basically the code is not something that's alien to you. You can understand how it works, right? So ballerina supports generating Docker and Kubernetes artifacts from code with simple configurations. And this simplifies the experience of developing and deploying ballerina code in the cloud. To deploy your code into different cloud platforms such as AWS and Microsoft Azure, annotations on service objects are used to enable easy cloud deployment. The ballerina compiler can generate artifacts such as Docker files, Docker images, Kubernetes YAML files, and serverless functions. So, like I mentioned before, ballerina has a graphical aspect to it via sequence diagrams. So, ballerina provides an intrinsic graphical view. So the unique graphical view of ballerina wasn't an afterthought. It was, in fact, it has been designed deeply into the language in order to provide real insight with respect to a functions or a services, network interactions, and their use of concurrency. So a sequence diagram is a kind of diagram that works best for that. So you can see that this is like a mix of a flow chart and a sequence diagram. So a function in a ballerina program has equivalent representations in both textual syntax and as a sequence diagram. That means you can switch between the two views seamlessly. And in addition to the powerful language features, ballerina is batteries included, which means that the language comes with a support system, right? And that means that the language comes with a rich standard library with libraries for network data, messaging, and communication protocols such as HTTP, HTTP2, NATS, gRPC, WebSub, WebSocket, etc. And we have a package management system which allows you to pull and push your ballerina packages. Then there's a testing framework, and we have extensions or plugins for popular IDEs, the most notable one being the Visual Studio Code plugin. and structured documentation, among other tools, to support the language. And if you want to learn more about the language, the website is the best place to go. It's got a wealth of resources and documentation to help you get started. And with that, I'd like to conclude my 10-minute presentation on the Ballerina programming language. I hope it was useful learning about the Ballerina language. Thanks for joining.
Thank you, Dakshita, and thanks to all our presenters. What an exciting day of sessions. We hope in our first ever KCD, you folks got a great experience about these open source tech stacks and got a huge knowledge of how these tech stacks impact with the best practices. So, we as a community love to enrich the community lives and to empower them to do with great things every day. We hope you enjoyed today's event. And we have a huge lineup folks who love to join in demo sessions tomorrow. We will be offering comprehensive live demo experience with wide range of speakers all around the world. Thank you for joining with us, and let's have a great KCDSL.